It's great to see like many new faces of faculty and students here. What we try to do in this time is really to bring the community together. Right? Like, so there's a lot of work around sustainability that's happening all across Tandon and then across NYU more broadly. And I think you're going to see some of that during the event today. It's also a great opportunity for us to connect with friends, across the country, for example. So we have Professor Meagan Mauter, who's going to give us our first keynote speech, but also connect with people here in the city. So you're going to see some key people from academia, industry, and government throughout the day, both in panels and in talks, but also use the time during the break in the middle and at the end to look at some of the amazing work that's happening across Tandon and in some of the startups that operate near us, right outside here. It's already great to see people already networking and talking about research right outside, and we'll have more time later. So before I pass it on to our senior vice dean, let me just quickly go over what we're going to be doing today. So first we're going to have a keynote talk by Meagan Mauter from Stanford University. We'll follow that with a climate mitigation panel. We'll have a quick coffee break, and then we'll come back and hear from Torres-Springer, who's the president of the NTA Construction and Development. And then we'll follow that with another panel which is focused on risk adaptation, climate adaptation and risk management. And then we'll have some time for network. So without further ado, I'll let our senior vice dean for NYU Tandon give us a few opening remarks. So welcome, Giri.
Thank you. That works. Can you hear me?
Yeah.
That's great. Well, I want to welcome you all on a Friday afternoon, and you must be here because you're passionate about the subject and you want to discuss and you want to make a difference. It's you know that humanity is changing and facing unprecedented environmental and societal challenges, and we not only have to, as engineers, not only have to adapt, but also engineer the transition to new economies and new ways of doing things that doesn't damage the environment. Sustainability is one of Tandon's priorities, one of 6 core impact areas that we decided to focus on because we have strengths in and because it's the right thing to do. It's one of the humanity's greatest challenges. So I want to say, some of the foundations of this initiative. When I first became the department chair, I cooked Turkish dinner for a group of the faculty, and I see the heads nodding. Andrea was there and Miguel was there. And it was a working dinner. I didn't even participate in the discussion. But they came up with a comprehensive approach to framing our climate challenge. And they said, we'll have a comprehensive framework called MRAD. How many of you know what MRAD is? Right, so let me tell you about MRAD. It stands for avoiding, so preventing emissions and pollutants whenever possible, so that's sustainable manufacturing in every areas, not only, for example, chemical engineering, but everywhere. Mitigating, that is capturing the pollutants when you can't avoid it. And then remediating, the R is for remediating, cleaning up the damage that has already occurred. So we've erred, but now we have to, and if you can't do any of those, then we have to adapt. And that's creating resilient systems, predicting, for example, flooding, and so on. So this comprehensive approach is actually unique. We have strengths in all the areas at Tandon. But I think we can also use it in our education. That is, educate our future engineers to be literate in all those areas and sustainability. And weave it through really our curriculum in all disciplines. So what that means is that we're asking, how does a mechanical engineer, chemical engineer, electrical engineer, computer scientist approach their field, their designs, their products with MRAD in mind? So this roundtable, this workshop that you're going to have is about knowledge transfer, and it's about taking cutting-edge research happening in the labs and what you're doing and translating it to teachable moments, to education, and into curriculum. So I encourage you to connect. I think you will, about new curricular and co-curricular opportunities that can be implemented to shape the next generation of engineers and their education. So I won't hold you off. Thank you for being here, and thank you for caring.
Okay, thank you, Erin. Hi, everyone. I'm Andrea Silverman. I'm a faculty member in civil and urban engineering. And I've had the pleasure of being able to co-organize this event with Miguel Modestino, Ingrid Paredes, and Yuki Miura. So big thank you to all of them, and also thanks to all of you and to our speakers and panelists for being here. It's an exciting opportunity for us all to be together. I have the honor of introducing our first speaker, Professor Meagan Mauter. Dr. Mauter is an associate professor at Stanford University and a senior fellow in the Precourt Energy Institute and Woods Institute for the Environment, which are both at Stanford. At Stanford, she directs the Water Energy Efficiency for the Environment Lab with the mission of providing sustainable water supply in a carbon-constrained world. Importantly, in addition to the work that Meagan does with research with her lab, she also serves as the research director for the National Alliance for Water Innovation, which is a $200 million Department of Energy hub that addresses U.S. water security issues and targets early-stage research and development of energy-efficient, cost-competitive technologies for distributed desalination of non-traditional water sources, which is super important in many parts of the country and the world in getting the water resources we need. As we'll see from her talk, Dr. Mauter's research is interdisciplinary at its core. She's had a lot of experience combining engineering, policy, and economics, which we also know is really greatly needed when we think about climate change, environmental challenges, and strategizing mitigation efforts. This shows in her training, where Professor Mauter holds bachelor's degrees in both civil and environmental engineering and also history from Rice University. She has a PhD in chemical and environmental engineering from Yale University. And before joining Stanford, she served as an Energy Technology Innovation Policy Fellow at the Belfer Center for Science and International Affairs, and was also a visiting scholar at the Mosavar Rahmani Center for Business and Government at the Harvard Kennedy School for Government. So without further ado, I'm going to welcome Meagan up to share what she's going to share about her research.
Thank you.
Great.
It's gonna warm up.
There,
Good.
got it.
Okay.
Cool.
Um,
Do you want a mic?
if I project, can you all hear me, or do you want me to do a mic? Okay. I'm gonna project. If you can't hear me, just stand up and wave halfway through the talk, and I'll go back behind the podium. But I'm short, and I'm wearing a big puffer because it's cold here in New York, so I don't want to hide behind the podium. I'd much rather see the audience. Thank you so much for bringing me here. It's a pleasure to be back in New York and really, frankly, reminded while walking the streets of New York just how important infrastructure is, both in big cities and elsewhere. But in New York, it kind of like hits you from all sides, the ways in which infrastructure is so pivotal to security, to affordability, and to sustainability of urban environments. And I think what's so interesting about what we're here today to talk about is the ways in which climate change is stressing that infrastructure, right? I work primarily in the water infrastructure space and am keenly aware of the ways in which climate change will be felt through the water cycle. We're looking at a future with much less water, as well as much more variance in our water supply. And so, as Andrea mentioned, as the research director for the National Alliance for Water Innovation, a big part of our research portfolio is in how we can affordably tap non-traditional supplies to help backfill that need in terms of augmenting supplies that are otherwise impaired by climate. Specifically, looking to tap these diversified sources, but to do so in a way that is adaptive, so that we can tap those supplies when we face droughts, but simultaneously use water infrastructure to help manage floods that we also expect in other parts of the world. We're also deeply invested in this mitigation idea, right? As you start to tap more challenging water sources, doing so usually requires more energy. And so we are deeply invested in exploring ways to avoid both increased costs as well as increased carbon intensity associated with tapping those non-traditional supplies. So I'll say that while this vision is, I think, both very compelling and very important for the water space, it would be remiss of me not to actually acknowledge a lot of its origin, which frankly comes from the power sector. I like to say that the power sector is just 30 years ahead of the water sector in many respects. We've actually, a lot of our R&D agenda is very much pulled from a tradition that was in the transition that's really grown in the power sector around decentralization. We are seeing a massive change in how infrastructure services broadly are being delivered. This movement away from very centralized systems operation to much more what I call 5D type or 6D type infrastructure systems. I firmly believe the future of secure, affordable, and sustainable infrastructure services lies on these dimensions, and I want to talk through them for the power sector and then help you understand how we translate that to other infrastructure systems as well. So demand softening, right? Like targeting energy efficiency. There was huge first cuts at that, especially 30 years ago in the power space. A transition to focusing on decarbonization, right? Both carbon capture, but also the use of renewable energy technologies. We quickly realized that a single renewable energy technology wasn't going to work very well. We need to localize energy supply, and that requires diversification. It also requires us to think about spatial and temporal needs of the energy sector and how you deliver infrastructure services that meet local demand, especially very local demand. That's often best done through a combination of centralized and decentralized supplies. We've had to address the resulting kind of mismatch in supply and demand through a decoupling effort, a lot of investment in energy storage and batteries, and you're starting to talk about controlling a very complex infrastructure system, right? It has hundreds of thousands of different components. It's acting in sub-millisecond time domain, and you can't do that with heuristic manual operation. This is a fully digitized future in the power space. Again, this has kind of been the roadmap for how we are thinking about where the water sector needs to go. We're further behind, but a lot of these same themes around relentless focus on efficiency. How do you decarbonize the water sector? How do you diversify sources, particularly finding ways to make non-traditional water supplies and on-site reuse more affordable. Decentralization, New York has been a real leader in that, actually. New York and San Francisco both. How do we decouple, right? What do we do when we have higher variance? How do we use our reservoirs differently? How do we use our groundwater aquifers differently? And again, although very slow, a movement towards digitalization, both in short time domains and long time domains for water resources management. I will say that while this kind of future in the power space has been largely successful, it's also a bit been a victim of its own success. Because a lot of the infrastructure we are now trying to develop and use electrification to help decarbonize is falling back onto the power grid in the form of peak load demand. And that's posing some very complicated challenges for how we both decarbonize other infrastructure systems, but also secure and affordably deliver power to all of those different sectors. In particular, recent estimates out of the Department of Energy before they took down this report, so you can find it on way back, but you cannot find it on the DOE website any longer, estimate peak load growth of 91 gigawatts over a very short period of time, right, 9 years. This estimate was from 2 years ago, and now is halved. Okay, so peak load growth is how, and is basically the constraint around which we design our power systems. This is because of data center growth, this is because of vehicle electrification rates that are faster than we expected, this is because of heat pump water heaters and home electrification, this is because of industrial electrification. And this is all very positive, right? This is an important part of our energy transition, but it's also hitting us in the pocketbook, and it is hitting us when it comes to how do we actually manage these grid loads, right? This is a CEO of Dominion Energy. This is the service provider for Northern Virginia. Northern Virginia is ground zero for data center development and co-location because of the defense industry there. And you are seeing just load growth that you cannot affordably accommodate on your existing grid. And so the implications are not just for affordability, they're also for how we're dealing with this is increased fossil energy usage and much slower than expected retirements. We're building tons of renewables, but you're only operating those renewables at 20% capacity sometimes, and sometimes less, like 10% capacity. That's expensive. We can build batteries, but that's very, very expensive. You can build new gas peakers, which we're doing a lot of, and you can increase transmission and distribution, but good luck building that, right? There's very little infrastructure being built. And so the alternative that has been deeply explored and yet inconsistently advocated for and implemented is one of distributed energy resource management. And the estimate is that you can deliver the same amount of grid stability at a fraction, literally 100 times less expensive to deploy energy flexibility resources than it is to try to upgrade and quote unquote modernize the grid or harden the grid to that new demand, that new peak demand. So what do I mean by distributed energy resource management? I basically mean taking power that would normally be consumed during highly constrained periods of grid use and moving it to periods when power is essentially free, if not negatively priced, which means that you have to pay to deliver power to the grid, right? So this seems very obvious, like huge arbitrage opportunity sitting in your lap, and it has absolutely phenomenal implications for the cost, again, of delivering that power infrastructure. We're talking about an avoided infrastructure investment of between $5 and $35 billion over the next 5 years. Everyone thinks it's on the high end. Much less renewables curtailment, significantly fewer emissions, and there's ample distributed energy resource opportunities. So this is a big space. The issue is that we've not been very successful in deploying those resources today. And we haven't been particularly targeted in understanding which sectors are constrained in which ways. So I've done a deep dive in my group, partially because of this balance of trying to look at both dynamic operation of water systems, but also how a dynamic water system interacts with a dynamic grid, to really deeply understand both what the magnitude of the opportunity is to use water resources infrastructure to provide demand response services to the grid, but also ways in which that delivery of flexible operation can help the financial bottom line of water utilities that are struggling to adapt to this changing climate. So I'm going to talk today a lot about water, but before I move on to talk about water, I want to emphasize that what I share in the water space applies very directly to most of the other sectors that are areas that you work on, but also deeply tied to the grid, right? When I'm talking about water, I'm talking about manufacturing. I'm talking about taking something and doing separations and doing a transformation on it where energy is my primary input. If what you work on falls into that category, I'm talking to you. And I shared in a science editorial a couple of years back my belief that this is the path forward for making carbon neutral industry, which is what we need to see here in the US, both financially viable and competitive with manufacturing elsewhere. So if you're interested in reading that, there's a lot of broad discussion about system attributes and infrastructure that we need to invest in. But I want to just highlight here that I think that the failure in some respects in the power sector has been in thinking very narrowly about designing and optimizing the power sector without simultaneously thinking about how we really do coupled systems of systems design right off the bat. So we're trying to build that into the water space, and I want to spend most of the rest of the talk today diving deeply there and trying to share with you our findings about both the opportunity and the barriers to implementation that exist. So water utilities consume a lot of energy, somewhere between 3 and 5% on average across the US, although there's a tremendous amount of variance there. If you look internationally, there's even more variance. 90% of Israel's water supply, drinking water supply, is from desalination. So the energy intensity of water infrastructure in other parts of the world is orders of magnitude higher than it is here in the US. Here in the US, it represents about a $4 billion a year expense and about 55 megatons of CO2 per year. The energy intensity of water treatment in the US is also growing quickly. A lot of that is driven by needs around adaptation. So significant expansion of desalination and reuse technologies, nutrient control, as well as long distance conveyance projects, pumping, that require a significant amount of energy. And again, these have orders of magnitude more energy intensity than most of our traditional supply, especially the supply of New York and San Francisco, which are both like largely gravity driven and no treatment systems. So lower, very little treatment systems. In addition to this rising energy intensity, we also are seeing a huge increase in energy prices that are paid by water utilities. So we've seen retail prices across California increase by 20 to 50%, and that pricing is largely driven by time of use. So it's much more expensive to consume electricity between 4 and 9 p.m. Often 4 to 50 times more expensive, depending on where you are in the country and who your transmission and generation provider is. So the concept here is how can we optimize the design and operation of our water infrastructure systems subject to production, quality, and cost constraints so that we maximize the amount of power that we consume in off-peak hours and minimize the amount of power we consume during these peak hours. And so our group has done a ton of work in looking at 2 forms of ways that we can shift that load. The first is very traditionally, like do on-site generation and storage. This isn't actually very practical for water systems, frankly, because you're always land constrained, but utilities are really interested in it because microgrids and this like idea of resiliency in the face of both uncertainty and grid reliability, but also natural disaster. So there's often a lot of resources there, but frankly, it's rarely the right solution. Diesel is high energy density, and you can get it and store it in a disaster, and so everybody still has their on-site diesel generator, right? Which makes these kinds of systems pretty attractive most of the time. The other option is to use the existing assets as a virtual battery. And so when we look across the water supply chain, we look at a lot of pressure, like a lot of pumps, right? You're pumping water over mountain ranges oftentimes. changing how we treat water, changing recovery, for instance, or what kind of treatment we use, changing distribution timing by leveraging storage reservoirs throughout the system, and also changing how and when we derive power from our wastes, really controlling power plants and turning them, controlling wastewater treatment plants, and even turning them into virtual power plants that can combust biogas when the grid needs it and consume electricity when the grid doesn't need it. So in addition to that concept of general price-based demand response, there are also a series of programs around more emergency situations. The grid is experiencing more stress than expected by forecasting agencies, and they might call an incentive-based demand response or call on the incentive-based demand response program. Here, the power utility invites bids from a water utility, and the water utility would bid at a capacity. And then if that grid was constrained, the power utility would call on the facility to shut down during an emergency event. And the payment back to the facility is calculated based on the fraction of the bid delivered relative to the baseline. So they don't cut you off of power, but there's financial incentives in either direction to make sure that load flexibility is delivered or load shedding is delivered when the grid is constrained. And so our group has done a lot of work exploring this in a facility or set of facilities in Santa Barbara. We've looked at the distribution system, we've looked at the wastewater treatment system, we've looked at the desal plant. I'm going to go into the desal plant in a little bit more detail here. The desal plant has a lot of flexibility in terms of how many treatment trains it can run at a given time. So it can either run 2 or 3 or 0. And in how much water it recovers, so what the pressure that you're operating your pumps at would be. And they are really motivated to do this because their power costs have doubled in the past 5 years, and the rates are deeply unaffordable. It's $10,000 an acre foot for water in Santa Barbara. And the reason that you can see here the opportunity space, there's a 13 cents a kilowatt hour weekday off-peak charge, and 53, it's actually now 57 cents a kilowatt hour for peak demand price, so time of use pricing between 4 and 9 p.m. So there's a genuine arbitrage opportunity here. There's also a pretty big spread in your carbon intensity of operation, and so they want to be a carbon neutral desal plant. They buy fully green power from the grid, but the reality is that at the node they're consuming at, the fact that they're buying totally green power doesn't really matter. What matters is what's happening at that node on the grid on the margin, right? So they can still contribute to decarbonization if they shift to accommodate the carbon intensity of that power as well. Okay, so we did both a virtual pilot plant model, and then we actually deployed a combination of tariff-based optimal operation and IDDR bidding strategies for a month over the summer of 2024 at this plant. And what we found is that during winter months, they can save about 4% on their power bills. During summer months, they can save over 15% on their power bills. That is significantly increased if they also choose to participate in incentive-based demand response programs. They can save about 1/3 on their power bills on a monthly basis. And because this facility is jointly metered with their wastewater facility, if they actually did joint optimization across both of those facilities, they could save an additional 10 to 15% on their power bills. That basically gets you back down to the power prices they were paying 5 years ago, which is a huge win for the city. It's an even bigger win for SCE, which is very, very node constrained in Santa Barbara and is desperately looking for ways to meet the demand that they're seeing from vehicle electrification and from home electrification. So this seems really obvious, right? There's this arbitrage, like a financially viable arbitrage opportunity sitting there. Why aren't we doing this? And that's really what our group has then turned to over the past 2 years. And we saw 3 key knowledge gaps. The first is, what are the incentives? Like, we did a case study in Santa Barbara, but what does this mean for the rest of the country and the rest of the world? How do we design for flexible operation? Most of the optimization we do for design today is for static system operation. And then most of the optimization that we would do for controls is for 15-minute intervals. But we actually don't see today viable strategies, computational strategies, for merging those timescales. And so we've done a ton of work in developing new optimization protocol and algorithms that allow you to do that coupled design. And then this challenge of how do you earn the trust of operators to step in and actually do real-time control of energy systems of their plants. I'm going to spend most of my time today talking about this because I wanted to share something that was broadly applicable across many sectors. But I'm going to very briefly touch on those other 2 things at the end. So, okay, here's my hypothesis. Why don't we do this? Well, the first reason we don't do this in water utilities is that the people that pay the power bills are not the people that run the plants. Okay? There is zero visibility into what on earth this is costing when you do your like super energy intensive backwashing at 4:30 right before you leave at 5 o'clock at the end of your shift, right? So there's just no visibility back and forth, but it's actually far deeper than that. It's hard for consulting engineers that do design and operators that are running plants to make sense of energy bills. Like that whole energy bill I just showed you for Santa Barbara, there's demand charges, there's peak, there's off-peak, there's summer rates, there's winter rates. It changes every 3 months. Like, how is one supposed to make sense of this, right? And so we did a survey actually just to like understand how different are utility rate structures across the 100 largest water and wastewater utilities in the US. That was published in Nature Scientific Data last year. We since expanded this, and I'll show you in just a minute. We have now every single industrial and commercial tariff for the US in a single data set that's openly accessible on GitHub. The second issue is that you're often, you're a good public agency, you really want to be carbon neutral, you also can't make sense of your scope 2 emissions, okay? So in California, where Santa Barbara sits, they have a CAISO generation mix that looks like this, right? You have gas peaker plants, and you've got some renewables, and you've got some hydroelectric and nuclear and some other stuff. And this leads to huge dynamic changes in your carbon intensity, your average carbon intensity, as a function of time of year, so month to month here, as well as time of day, right? This is the storied duck curve in terms of carbon intensity for CAISO. That's all well and good on average, but actually I don't care what my average emissions intensity of the grid is. If I'm a large load, what matters is what's my marginal emissions intensity. And that too varies tremendously. We see that your marginal emissions intensity actually varies more in terms of time of month time of month than it does between months usually. So that's really hour of the day. And often more hour of the day than it does based on where you are in the US. So there's a huge amount of complexity underneath here and really no transparent mechanisms for accounting or tracking what those marginal impacts are or how to use that as a signal against which you would dynamically operate the plant. So as I said, we endeavored to solve this problem, at least from a data accessibility perspective. We collected all US industrial tariffs. I should say my wonderful undergrads collected all those tariffs. I had nothing to do with it. We also looked at day-ahead market prices and incentive-based demand response programs. So we now have a unified data set that for the first time represents all of the features of these tariff structures and demand response incentive structures in a single place and have proposed ways to basically represent discrete data continuously so that you can make apples to apples comparisons, not only between IBDR day ahead and tariff structures, but also, which tariffs are basically assessed monthly, right? Because you have monthly demand charges, but also to be able to directly compare those with real-time emission factors, so marginal emission factors and average emission factors across the U.S. And those we relied on other people's methodologies, but we re-implemented them in conjunction with our tariffs. And we've been using that to answer a series of questions around upper bounds of cost and emission savings from flexible operation, very generically. So, where do you want to cite in terms of maximizing savings from energy flexibility? How aligned are emissions and cost incentives for customers? What's the magnitude of the incentive as a function of the load shape? Some industries are super flexible and have loads that can be shed very easily. Others are wastewater treatment facilities. And frankly, you can't just stop treating wastewater, right? You have to treat it if it comes into the plant. So you have limited flexibility in some of those facilities. And then we're really trying to understand the degree to which this is a cost-effective flexibility is a cost-effective emissions abatement strategy, right? And can you find ways to monetize your emissions abatement so that you can afford to do flexibility upgrades to the plant? This is basically getting other infrastructure or other sectors to pay for water infrastructure upgrades. So I'm going to go through some results on this quickly, not in a tremendous amount of detail, but I can come back. We've done a lot of work on how much can you save as a function of whether your metric is average emissions factor, marginal emissions factor, day-ahead market price, or tariffs. And what we see is that your day-ahead market prices in most regions are definitely dominating your energy or your cost savings opportunities, but there's still significant cost savings opportunities in the tariff space at certain times of day. Your flexibility favored tariffs are driving value, and the upper bound for savings is actually far greater than that I reported in Santa Barbara. So there's a lot of costs behind the meter cost savings opportunities to match a lot of the front of meter grid cost savings opportunities that I highlighted earlier. The second thing to note is that emission and cost incentives are actually not aligned. So they're aligned for the day-ahead market, but they are deeply disaligned or misaligned for tariffs. And that's bad news, right? That suggests that if you want to save money, you're actually going to increase your emissions intensity. A lot of that is actually a function of congestion in transmission and distribution infrastructure. So we need to address those bottlenecks first and foremost. But it's not actually always congestion dominated. Sometimes it's just a function of not wanting complex tariffs. And so there's actually also a real policy opportunity for adjusting tariffs, both to account for the costs of carbon, but also to help align, when not congestion constrained, to align cost and carbon incentive structures around flexible operation. As I mentioned, the benefits of flexibility are very, the kind of magnitude of benefits you can get from flexibility are a direct function of what the load shape is of the power consumer. So if you're an industrial manufacturer and you shut down every night, you stop making hot dogs, I don't know, whatever you're making, right? You may have a lot of your ability to kind of take your system down fully. We can also think about dimensions such as power capacity, energy capacity, round trip efficiency, right? Things to describe load shapes. And so we've gone through whole ranges of industrial load shapes and looked at the magnitude that different sectors on average may have in terms of cost savings opportunities as a function of their load shape. And then we've made that very agnostic and said, okay, we can parameterize load shapes and load attributes and look at how their value of flexibility changes. I'm going to go through this quickly, but I'll just say that there is a lot of change based on what your load shape attributes are. And so really better understanding how load attributes and grid tariff prices and incentive structures interact becomes really important for design of electrified and dynamically operated systems. I'll just conclude by saying that we try to make quantitative the degree to which different load shapes the effective cost of flexibility is compared to other metrics for cost of carbon reduction. So you're thinking about, how do you, if you were to shift load and it was to cost you more money because you're consuming more costly electricity in shifting that load out of a high carbon intensive period, what's the effective cost of carbon of doing that shift? And what we found is that load flexibility is actually a very cost-effective emissions abatement strategy. So this is the social cost of carbon. Almost everything's below that in terms of cost of abatement. And these bars are renewable energy credit prices in different markets. And so what we're seeing is that investing in flexibility is a much cheaper way to abate carbon emissions than most other investment opportunities. Okay, so that's kind of like very generic load flexibility, what's the value? We also wanted to make this very specific to the water sector, so the sector that we care about. So we wanted to answer questions related to what's the value of this flexibility from the water sector relative to other grid scale energy storage and flexibility solutions. So we took models of facilities and tried to describe those in terms of metrics that matter to grid scale energy storage, things like round trip efficiency, energy capacity, power capacity. And then we wanted to also more broadly address this question of what's the behind the meter value to the utility. And we need, in doing so, talking about net present value, levelized value flexibility, and the effective implication that that has on the cost of water, we needed to account for all the things that plant operators care about. What's the capital cost? What's the cost of that capital upgrade? How much more quickly is this going to, decrease the performance of my pump because I'm turning it on and off all the time, right? How much more maintenance am I going to have to do? How much am I going to make from doing this, right? What's the cost of not delivering water at that time of day because I have to store it somewhere else, right? So we really wanted to ground this in things that water utilities cared about, and then look at a wide range of facility models in the water space that could help make us or help us ground our understanding of the opportunity space here. So we did that. We used canonical systems. We also ground truth systems outside of Santa Barbara. And at a very high level, this is all published, and you can actually play around with the models on Marimo, which is a kind of online way to interact with models that are have back-end sophistication, but make them very user accessible. We found broadly that the cost of energy flexibility from water sector utilities is cheaper than the cost of grid scale energy storage projected for 15 years from now. So these are not today's prices, these are prices for 2040, the projected prices for battery energy storage in 2040. So we're kind of optimistic that if there are capital upgrade costs, if it doesn't cost you very much to implement this flexibility, that it's beneficial to look to the water sector as a source of that load flexibility, and that there's actually tremendous value there for water utilities. I'm actually going to stay on target and skip this slide and just highlight and move on to our these next two sections, which I'm going to go through more quickly, but just say that we have design, it's all well and good to say there's a big pot there, not just for water, but for other industries. But we're still burdened with this question of how do we do design and how do we do operation, right? So I want to jump very quickly into an example of a facility that we're working very closely with Silicon Valley Clean Water. It's a wastewater treatment facility that serves Menlo Park, Redwood City, Atherton, and a couple other communities right in the Bay. It's a really interesting facility in that they have an on-site and have long had an on-site biogas generation program where they produce about 61% of their own power from biogas. But that is also a facility that is struggling very deeply with increased power prices from PG&E and large new loads that are about to come online associated with water reuse. So they are very desperate to think about ways to more affordably deliver water. They have the highest wastewater rates in the Bay, and it is about double the wastewater rate that the surrounding communities pay. So we endeavored to do two things. We wanted to help them get much more out of their biogas. They also flare a lot of their biogas, and their biogas utilization factor is not good. It's about 80%. And we wanted to help them, more importantly than just not flare, make financial best use of that biogas generation and do that by both shifting load to times of day when biogas is available, but also figure out other ways to store energy so that you have even more load flexibility. So we developed a optimization algorithm that bridges long duration planning with short duration operations to inform which investments this facility could make in flexibility to be able to more fully shift load out of these time of use periods. And in order to do that, we looked at a whole slew of different energy or effective energy storage or load flexibility opportunities. So you can store raw wastewater. They have a huge interceptor that's used only when it rains, which is to say pretty rarely in California and the Bay, but they need it to avoid mine sewer overflows. When it rains, between December and March, you need that interceptor. Summer months, not so much. So there's wonderful water storage opportunities, and you can do that for 24 hours without it going anoxic. So we're conscious of constraints, right? You can store primary effluent for a much shorter period of time. They are actually in the process of building food waste storage and fat, oil, and grease storage, which is very energy-dense feedstocks into the digester. They could potentially store biogas, but it wasn't economically viable, so I'm not going to talk about that. They can change when they blend natural gas with their biogas to increase the BTU value. They can install a battery on site, and they could install new generation capacity, high efficiency generation capacity, in the form of linear generators that don't push up their air emission pollution or air emissions, which are problematic in Redwood City and wouldn't be permitted. Okay, so we account for constraints at the plant, but you can see we've looked at a lot of different mechanisms for injecting flexibility into that plant. Each of them has unique energy dynamics and cost implications. The storage is highly interdependent, right? If you start to store raw wastewater, you're not generating biogas, you're not feeding your generators, you're not charging your battery, etc. The cost optimal configuration is, there's no right answer for all times of year, and there's no right answer for all facilities, right? This is incredibly facility specific. You need digital twins of physics-based and data-driven, I should say, data parameterized digital twins of those plants, and we need to be able to ask what-if questions about changing the operation of those plants. And you have to make control systems risk-aware, because if it rains, you are not using that interceptor to do any wastewater storage, right? So we've designed a lot of kind of back-end processes for optimizing not just the size of different storage attributes, but also which storage attributes you want and which combinations and which have the highest returns on investment. Of course, this is in addition to the returns that you get from having the environmental benefits of having raw wastewater storage, right? But the marginal cost of building more raw wastewater storage when you're already building several $100 million storage thing is not high. Your upfront costs of building any infrastructure are large. Your marginal costs of making the infrastructure a little bit bigger are almost zero. So it is a lot about how do you build that into existing capital improvement plans to enhance flexibility before it's even necessary in today's energy markets. We're also turning now not just to design, but we wrote a grant to the California Energy Commission that got funded, and we're doing an $8 million demonstration project at this plant. We've bought 5 linear generators. We're controlling a battery on site. We are controlling the digester dosing with fats, oils, and greases, food waste, and sludge, and its operation. And the goals of this pilot are really to optimize the use of the assets to minimize grid energy during peak hours and allow this plant to expand participation in these energy demand response programs. So really excited about this. In order to make that happen, we've had to build a lot of back-end tools around data screening, ingestion, physics and biology models and data-driven models of what's happening in the plant, a lot of model predictive control, and then an application layer that the utility operators understand and can interface with the APIs for the battery system and for the linear generators. We are in the process of fully building out all that infrastructure, but right now we're running a virtual plant, so a virtual pilot. And what we're observing is that our energy savings from this plant is in the wintertime approaching about 23% of their bill. So again, a really significant fraction of what it costs to operate this plant is being enabled or affected by better management. The other thing I want to point out that I forgot to point out earlier is just that what we're not doing is messing with water treatment. Right? Like, no operator is going to let us change the water treatment. And good luck if you want to do anything here. But they're very happy to turn over a lot of the control of this incredibly complex system that is not central to their license, right? And I think that this is a broader way to bring design and control into plants is through peripheral activities that aren't necessarily as core to their day-to-day lives, get them familiar with collaborating with models that make recommendations. And then I think slowly that's how you end up also bringing automation and control into more competition. Okay, I want to just wrap up by saying I think that hopefully I shared today that a lot of the opportunity in infrastructure design is about coordinating across infrastructure sectors, both in terms of what infrastructure we build, but also how we operate that infrastructure. And doing so is going to be absolutely imperative to delivering secure and affordable and sustainable infrastructure services in the future. I work so much on water, and I'm really excited about the ways in which flexibility also helps us deal with that variance, right? I'm hopeful that we can actually afford to finance new water infrastructure, do the adaptation we need to do by making it profitable to, in wet years, deliver lots of energy services to the grid, and in dry years, crank up those desal plants, right? Because you're going to need that to make water systems supportable. And with that, I just want to thank my group and the broader NOWI community here that helped make all this work possible. Okay? I have no idea what time it is. Sorry.
Since the optimization operation is so site-specific, that means your software modeling package are also incredibly site-specific, right?
No, well, no, you do not want to build site-specific modeling software. You need to develop data ingestion platforms, and we've done a lot of work on data ontologies and metadata schema that will allow us to represent plants very quickly, bring that data in an organized fashion, pair it with a physics-based modeling library and optimization tool that we have, and interface that design optimization with model predictive control tools. You really have to think about pipelines from start to finish if you're going to make this scalable.
I think robustness was a concern there, so we digitize systems.
Yeah.
One more question.
It's like right, she said. She was getting.
So from what I understand, high capacity battery technology continues to be like one of the factors in basically all of this. And so I was wondering if there's been any major developments in the past years that have significantly affected the capacity of these high energy battery systems.
Yeah.
And if not, do you anticipate there being major developments in the coming?
Yeah, it's a great question. I mean, one of the risks is that you end up designing for a lot of energy flexibility, and then there's like a magical battery technology that undercuts all of those investments, and like that would be great for the energy system, but really bad for water utilities that are banking on this, right? So we recommend when we're working with utilities that you don't invest in anything that has a payback period of longer than 5 years, because I don't know what's going to happen in battery innovation and grid scale energy storage prices, right? What I will say is I think that's a very conservative estimate. All I've seen is battery prices, unfortunately with tariffs especially, like grid scale energy storage prices are going up right now, they're not going down right now. There's also so much curtailed renewables on the grid and so much transmission limitation that effectively, and so much power demand, that like there is, I won't say infinite, but nearly infinite capacity to absorb new storage on the grid and still see local value from distributed energy resource management. Because a lot of what's constrained is local, not grid scale energy storage. Like in Palo Alto, I serve the Utilities Commission, we just got a big grid scale energy storage project, but we're doing that in Southern California, right? So like it's not actually helping our distribution system or transmission issues locally, and you do that because that's where the cheapest grid scale energy storage is. But again, like the front of meter distribution and transmission benefits aren't being realized locally. So we still think that there's a tremendous amount of value in local DERMS projects, especially in places that have constrained nodes.
Good afternoon. I am really excited to be here because I'm really excited to be here this afternoon to moderate a panel focused on climate mitigation strategies and the New York City climate tech ecosystem. Thank you to Miguel and Andrea for inviting me and our panelists to today's summit. I think as members of a diverse academic community, there's a lot of engineers here, I'm sure, today, but probably also some folks from some of the other NYU schools, from business, science departments, etc. We're all acutely aware of climate change as the defining challenge of our generation. And from Megan's talk, I think if you didn't know before, the problems are complex and multifaceted and demand innovation, not just in technology, but also bold action in governance, urban development, economic strategy, human and corporate behavioral change, etc. The urgency of the topic is clear, and solutions are going to require all of us to come work together. The panel this afternoon, we're going to explore and examine some of the tangible on-the-ground strategies that are being developed here in New York City to support innovators and entrepreneurs in this space so that they can help develop some of those solutions. Our goal is to connect the impactful research and intellectual curiosity here across all of NYU with the dynamic ecosystem of climate innovation that is rapidly evolving around us. So over the next 45 minutes or so, we'll hear from leaders who are driving this change in the city across different sectors. And say Seema from the New York City Economic Development Corporation, and members of 3 climate innovation hubs here in the city that NYCEC has helped to establish. Gina Horowitz from the New York Climate Exchange, Alice Mitchell from AdWorks, who will share visions of the two new members of the ecosystem, both of which NYU is a founding member of, and Austin Everts from NYU's own Urban Future Lab, who will bring the perspective of a more long-standing incubator in the city. We hope the panel will spark ideas for your engagement and collaboration with the New York Climate Exchange, AdWorks, the Urban Future Lab, and more generally, as well as illuminate the entrepreneurial and career pathways that are opening up in New York City's green economy. So first off, I would like each of our panelists to introduce themselves and their organization, and then we'll move into some questions. And let's just start with Alex, since you're right here.
Sure. Thank you so much. Alex Mitchell. I am with Los Angeles Executive Incubator, as you mentioned, alongside NYU, City University of New York CUNY, and Cambridge Innovation Center. We have the 4 entities that are driving forward, I think, the newest innovation hub in the climate space in New York City, which is called AdWorks, Brooklyn on New Terminal. We have just begun on the programming side and are also designing what the future of this campus will look like, which will be roughly 200,000 square feet of innovation space across co-working, labs, prototyping and assembly facilities, et cetera, at the Brooklyn on New Terminal, all that I on.
Hi, it's nice to be here. Thank you for having me. This is giving tickets. So I'm with the New York Climate Exchange, which is no longer the newest kid on the block, although still pretty young. We are a nonprofit organization dedicated to accelerating climate solutions. And really core to the way that we do our work is thinking about breaking down silos and really structuring collaboration across academia, industry, government, entrepreneurs and innovators, and sort of people of all stripes who really need to be at the table to drive systemic change and impact when it comes to working on climate. And we are developing a dedicated climate campus on Governor's Island. I don't know if anyone in the audience has yet been to Governor's Island. Today is probably not the best day to go, I will admit. But it is open and operational full year. And we are building a campus there that will be a home and a kind of center of gravity for all of our activities. It's just in New York Harbor, it's a stone's throw from Wall Street, which we can get into in a bit in terms of how that factors into our vision. But once we are up and running on the island, we will have a range of different activities that again kind of represent what's needed to drive systemic change for climate. And so that includes higher education, research, tech incubation, workforce development, and real cross-sector convening. And I would be remiss, given the venue, to not mention that NYU is one of the founding academic partners in our 48 partner consortium. So we have NYU, we have 10 other academic partners, dozens of different community organizations that range from kind of stewardship, folks who have been kind of deeply involved in this work for decades, frontline environmental justice organizations, labor unions, really a cross-section of kind of what New York has to bring to the table again to work on climate. And excited to be here with you.
Hi everyone, I'm Isaiah Savon. I'm with the New York City Economic Development Corporation. And EDC is the entity behind AdWorks. We have a connection to UFL, helped to fund UFL at the very beginning and in an ongoing way, and then continue to partner with the Climate Exchange. EDC is the city's economic development arm. We are a quasi-public entity, which allows us to work flexibly. And so we have sort of 4 key movements. Beyond sort of driving the growth and diversification of New York City's economy, we build large-scale infrastructure. So we're building places where people can live, learn, work, and play. One of the places I'll talk about later on is in Brooklyn, the Brooklyn Marine Terminal. That is slated to be a 66-acre port that will integrate housing, a working poor, and also be a hub for our Blue Highways initiative, which I'll talk a little bit about later. But that's one example of the types of scale neighborhoods we build. We operate a lot of sustainable infrastructure on behalf of the city. So if anyone here has taken the New York City ferry, EDC manages that on behalf of the city. We invest in supporting our innovation sectors in the city, and so a lot of the reasons why we have connection to the various incubators and accelerators and hubs on the panel is because we're really committed to ensuring that New York City's economy is diversified from the typical fire, finance, insurance, real estate sectors to also include things like the green economy, life sciences, creative and applied tech. And so we made investments in those sectors with a real focus on equity. And then finally, we are sort of the front door to the business community. And we're able to do that through leveraging 64 million square feet of real estate assets that we manage on behalf of the city. And so that's everything from large-scale ports, some of which we activate for renewable energy generation. I'll talk a little bit about that. To the ground lease under Metro Center, actually, which is the easy managed asset, right? So we have campuses where we're sort of engaged in very direct active management, like the Brooklyn Army Terminal, to longer-term ground leases. And we're trying to do all of that with a commitment to advancing the economy.
And I'm Austin Everett. I'm the director of the Acre Incubator at NYU Tandon's Urban Future Lab. We are the longest running think tank incubator in New York, originally started in 2011 in partnership with the state. We have 5 active climate programs. We have 3 accelerator programs, a professional development program, and an incubator. Our 2 accelerator programs are our Carbon to Value initiative, which is all about supporting carbon technology companies. Our Offshore Wind Innovation Hub, which supports offshore wind innovation. We have a program called Innovate UK, which is a landing pad program for clean tech companies coming to the US from the UK. Clean Start is our professional development programs for mid-career professionals who want to transition into the clean tech industry. And then last but not least is Acre, the program I work on in actually just across the street at 370 J Street. We support companies, early stage companies with fundraising, securing pilots, hiring, and design. Because we're part of NYU, we were always trying to connect with faculty, with our companies, and ways that they can work together, as well as talent students through internship opportunities. And we're a nonprofit. We don't take equity, so we're very first. We supported 170 companies today. They found and raised $3.9 billion in follow-on funding, created 5,000 jobs. Most of those are local, and have 93% survival rate of event. That's the all go.
Which is really impressive. All of us are very impressive. So I think the next round of questions, I want to delve a little bit deeper into each of these, give you a little more insight into what they uniquely offer. And first I want to start with that saying, and get a little bit more of a background on what the city has been planning and is doing and will be doing. So this sort of probably predates, but certainly goes back to the Green Economy Action Plan that came out of NYCDC and the Mayor's Office a few years ago, establishing the Climate Harbor Collaborative, which includes the New York Climate Exchange, includes the Brooklyn Army Terminal, also the Brooklyn Navy Yards. I'm just curious if you can give us a quick update on where we are, where we're going with the plan. You alluded to a few pieces of it, in addition to the Climate Harbor Collaborative as well.
Yeah, sure thing. So at the beginning of last year, the city put out, in collaboration with AEC, the New Economy Action Plan, and they really articulate our vision for ensuring that our energy transition creates deep economic opportunity for New Yorkers alongside all of our environmental goals. And so what that means is we wanted to make sure that we are making encompassing investments to support the types of companies that are going to be at the forefront of our energy transition, to support the workforce and the training that is needed to enable that transition. And so in that vision plan, we laid out a couple of key goals. We talk about decarbonizing buildings and construction, just given how much that contributes both to emissions in the city as well as what we forecast that area to be some of the biggest opportunities for job creation. We focus on building a renewable energy system, just obviously that's really fundamental, as we were sort of hearing in the last presentation, that's really fundamental to our transition. We focus on low emission transportation, and we focus on catalyzing climate innovation, and then finally ensuring that all of this is equitable, right? So look what kind of 5 big goal areas, and within each of those goal areas, we made a number of commitments as a city. Many of those commitments EDC is leading on behalf of the city, but they all require deep public-private partnership to really deliver on. And so I'll talk about a couple where we've made progress and where we have, a ways to go. So in decarbonizing buildings and construction, you've heard me talk about our 64 million square feet of real estate assets that we manage on behalf of the city. Given how varied that portfolio is, there is a really robust vision we have for decarbonizing as much of that as possible, but that requires a lot of nuance given the complexity of the portfolio. So we are making lots of progress in that. Everything from what seems like really basic lighting shifts, right, to much more complicated thermal energy networks that we're trying to deploy at sort of networked assets and sets that Park and Hudson White. On the buildings and on the buildings front, we are also really interested in embodied carbon and reducing embodied carbon. So we have under the Adams administration, there was a commitment through an executive order that we wanted to get to a 50% reduction in embodied carbon in city construction. And so, we think we're uniquely positioned to lead on that. We put out circular design and construction guidelines to help drive forward that vision. And so, because we work with the private sector pretty extensively in a number of development projects, we are now requiring that developers can take into consideration and apply those guidelines in their development bids to us, right? So that's in the building space. In the energy space, I mentioned before that we manage a lot of port infrastructure, including the South Brooklyn Marine Terminal in Sunset Park. That is an over 70-acre facility that has really become the linchpin in our ability to bring offshore renewable energy into New York City to be able to maintain and operate offshore wind farms from New York. And so that's about 75% constructed. We expect to, I think by spring of next year, you'll be able to actually see massive wind turbines on that site from the highway. We've also, as we make these infrastructure investments, we want to both make infrastructure visible and also the sort of the learnings. We want to make that really available to a broad swath of New Yorkers. So we partnered with Equinor on building the Offshore Wind Learning Center, which is really interactive space for K-12 folks and older folks to also get in there and learn about really how offshore wind works, right? We're doing a lot of work around supporting battery storage. We write the Special Oxygen Centers program. We've introduced over 400 megawatts of battery storage in New York City through that. We've obviously invested in networks, which I will let Alex talk more about when it comes to domestic climate innovation. And then the last thing I'll say, so I can give up some time, is around transportation. One of our big visions is around what we call the Blue Highway. Right, we want to take more freight trucks off the road and really leverage our 520 miles of waterfront that we have in New York City. We are expecting a 67% growth, which I still struggle to fathom. 67% growth between now and 2045 in packages. Sorry, it blows my mind. I don't know where did that look up? But the figures are coming. But there's a massive opportunity to ensure that whether it's packages that you're getting delivered from Amazon or aggregates for building construction, I can think about our priorities, right? So we're making lots of investments around that, including really advancing some of the core nodes in that highway network, including the marine terminal, Hunts Point. So yeah, lots of progress and lots of exciting movement.
Just it's incredible how much you're in the space and you're serving other urban centers, and I guess I'll have to say Los Angeles is also very good. We're doing so much, and definitely appreciate it. All people in the same are contributing. Shanna, I wonder if you could talk to us a little bit about the New York Climate Exchange. You mentioned campus on Governor's Island, which I call audacious. I think it's really a really fascinating use of space in such a special area. How do you see that location influencing what the climate exchange is trying to do, what its focus is, what the future plans are, and what does it make uniquely possible?
Yeah, great question. So the New York Climate Exchange's future home on Governor's Island is definitely integral to how we're thinking about the topics that we'll work on, partnerships that we'll establish to do that work. So for those of you, I saw at least one hand in the back who have been to Governor's Island, you can appreciate it's an 8-minute ferry ride from Lower Manhattan, but it's a 172-acre oasis just off the southern tip of Manhattan. And so it really feels like a different environment when you step off the ferry, and it's certainly a very visceral place to be thinking about and addressing both our research and the development of new ventures, issues of coastal resilience and rising sea levels, and a variety of different impacts that we're all already feeling here in New York City when it comes to climate change. And so we think the location of our campus in this type of environment kind of opens up some new headspace to do this kind of work, but also keeps it really rooted in the actual physical environment. It's also key that there are a number of great organizations already on Governor's Island who are partners of ours, and that we're looking to help kind of extend the impact of what they're doing. So whether it's on-island composting, students who are coming to school at the Harper School each and every day, thinking about their role as potential environmental stewards and pursuing different career paths in the green economy, building a oyster project, which is always a crowd favorite in terms of the work that they're doing to restore ecosystem health in the waterways around New York City. So we're excited to kind of build upon and build alongside a lot of the folks that are already on Governor's Island doing this kind of work. And then I'll say, again, I alluded to it earlier, that the proximity to Wall Street is essential. Climate finance is going to be a key area of focus for us, thinking about how can we be a leading hub for knowledge sharing, for capacity building when it comes to really thinking through and advancing the type of capital that's necessary to build infrastructure and really kind of move us in the right direction when it comes to climate interventions. And so that proximity to Wall Street, that partnership with that sector is extremely important to us. And then last of all, the campus that we're building, we're taking our own kind of vision and hope for the future and then pouring that into what we're actually building. So we're developing a campus that'll be the largest example of mass timber construction on the East Coast. We'll have a large undulating solar canopy that'll be a kind of signature feature of the new building. It'll be on-site geothermal. We're doing an adaptive reuse project for a building that already exists on the island. So we're really embracing our own development process as a chance to inspire others, hopefully. And in some cases, as anybody who works with startups can attest, no one ever wants to be the first customer, they want to be the second customer. But we feel we have a unique opportunity in some instances to actually be a first customer and market maker for folks who are at the cutting edge of developing new innovations that can help the city reach its goals that NC talked about when it comes to reducing the carbon footprint of construction and thinking about embodied carbon in the built environment. And so we're really embracing these next few years as we get underway with construction as a chance to really kind of push the envelope on making the island the test bed for new technologies and new innovations. And then the last piece I'll mention, and Alex will probably touch on this too, It's just the opportunity for doing sort of pilots and demonstrations, again, that would uniquely benefit from the type of island environment that exists on Governor's Island. So the journey from kind of lab-based testing to full-scale adoption is rife with very key opportunities for pilots and different chances to get the technology out of the lab into the hands of different users, exposed to different conditions. And through our partners at the Trust for Governor's Island, we're already seeing really exciting ways that the island is being activated in this manner. And over the next couple of years, the exchange will be increasing the pipelines of that type of activity and looking for more opportunities to support people who want to bring their work to life in a real world environment of the island.
Fantastic. And we're going to chat a little bit more in the coming questions. So Alex, I'm going to turn to you to learn more about Backworks, the new kid on the block. Still kind of an adolescent, like a toddler really, not even an adolescent yet. But how do you see Backworks adding to this equation, given that we have the climate exchange and we have other players in place? What is the specific niche that Backworks brings?
Well, like I said, this is the comments of a pre-adolescent, so maybe the ultimate what we become when we grow up might be a little bit different. But I do think there are some things where we have a really clear direction. One of the things that I was thinking about in the panel that preceded this is, the lamentable moment we find ourselves with battery costs rising rather than falling, which is change over what the situation looked like for the last many, many years. And I think there's one thing in Washington, D.C. that has very rare bipartisan agreement. Not a lot of that right now, but across both the Republican and Democratic Party, there's understanding that we are a nation that used to be very good at making stuff, whether that be infrastructure or goods, and we remain very good at making and shipping code and doing a lot of things in services, but we have lost an ability as a nation to really make the stuff that powers the economy. We saw how painful that is right now. We see how painful it is. Tariffs impacting battery prices. We saw it during COVID. There's a lot of pathways that will take, but there is an understanding at a strategic level that we need to be better as a nation again at making stuff. And as you think about that national strategic imperative, meaning the location of the Brooklyn Army Terminal, it was the location itself, 4 million square feet, set up by the U.S. Army, really focused on the logistics of moving people and goods in and out on those industrial processes of transformation. And it is an ideal canvas to think about, okay, if one of the strategic imperatives that the U.S. And the region is really making stuff again, we have a campus that is ideally suited to some of the light manufacturing needs that will power the climate economy. The Brooklyn Army Terminal is sort of an ideal adaptive reuse location to think about where climate innovation meets that industrialization and commercialization stage that startups are doing. So, Sheena talked about some of the fantastic links that the climate exchange has with academia and with Wall Street. I think we think a lot about that phase about a startup that says, okay, I've built my first maybe 1 or 2 prototypes, but now we need to get to the next stage, which is like building my first 50 units. I'm not yet a commercial scale manufacturer. So I need to build 50 units, get them out of the marketplace. And I also need to have a team of folks who can actually help me deliver that, whether that's building those units by hand or by some form of contract manufacturing, and also servicing those units in the marketplace before you reach that really large scale where you say, okay, now we can justify signing long-term agreement for factory elsewhere or locally. And the Brooklyn Army Terminal itself is again just an ideal campus for that. As Sheena talked a lot about the geographic attributes of Governor's Island and the climate exchange, and similarly, the Brooklyn Army Terminal is this insane multimodal haven. You've got a rail spur nearby, you've got trucking, you've got waterfront logistics. I think a 13-minute ferry ride from Wall Street versus your shore ride. But as NC talked about the Blue Highway, goods movement will be coming into the Brooklyn Army Terminal as well, not just people by waterways. So it's an ideal sort of location
to be thinking about the logistics part of industrialization and commercialization. In a difference versus what some of Sheena talked about on climate exchange, this is an adaptive reuse approach. So we are taking an existing building that's been built a little bit over 100 years ago. We are incorporating elements, some similar elements, including a mass timber roof on part of the building. But it's really about honoring that industrial working waterfront and that industrial heritage of the Brooklyn Area Terminal as it relates to climate topics. So that will be climate topics that touch building decarbonization, transportation, and clean energy, 3 sectors where we really feel like that industrialization and commercialization stage can be really well served. And by doing that by a variety of different services or focus areas, one is pilots itself, like how do you actually help innovators pilot their technology on this, again, 4.1 million square feet of built environment, part of an industrial working waterfront. So piloting and really helping startups validate their technologies, startup incubation. So how do you
startups to get through that commercialization and industrialization stage, which can be very tricky for startup founders? And how do we link that with workforce development? If you are really getting startups at that commercialization stage, that's when they start having to go from like, oh, we got a team of 4 to like, now we need a team of like 15, and there's some maintenance roles here and some assembly roles here. And so we think there's a really important opportunity to honor the industrial heritage and work tomorrow from the Brooklyn at that stage while helping startups go through scaling. And I think we find this very much with the eye towards cooperation, really being very complementary together. Operators in the marketplace, Shay and I have a number of conversations. There's so many things I think where the swim lanes sort of become very clear for startups and other things. Like I think when I think about nature-based solutions, I think instantly of the amazing, fantastic capabilities you have at Governor's Island. So I think this is definitely an arena where all of us think about our respective strengths and how we develop on those, and sort of share the wealth with the ecosystem when we find really cool startups who are like, how do we create Governor's Island?
Fantastic. I think that really helps sort of point out, like you said, some of the unique strengths, but then also some of the ways there's movement between. And so kind of point out, as a partner in all of this, I might do is participating in STEM outreach initiatives, education initiatives for K through 12 through adults. And I think the commitment of both to that and to community partner engagement, which is such a big part of it, has been really fantastic. Austin, last but not least. In my notes, I had referred to you as to Urban Future Labs as the veteran. So toddler to veteran. Somebody's going to refer me to OEO pretty soon. So UFL has been around, as you said, for 16 years. What do you think of these new kids on the block? How has that changed things for you? How do you see that? How do you see UFL interacting and your companies in particular benefiting from climate exchange and from that works? Yeah.
I was going to go with aging grandparents. So
just to be clear, I embrace it all.
Our philosophy is a rising tide lifts all ships. I think we're actively participating in these initiatives because we think they're going to expand our capabilities and make more value for the startups that we support. So one of our biggest limitations as a program is space. We don't have pilot space, we don't have a place for somebody to go. And they need to do that like early industrialization first before units. So our goal is that we would send our companies as they're scaling that to these programs. I think it also opens us up to new verticals. We have to turn away maritime companies in the past, for example. AdWorks has an active waterfront, like that's an area we could collaborate on. And then I think, it goes both ways too, like being here for so long, we have a really strong pipeline into climate finance, into resilience into these areas. So we like to ensure that the best of the issue that it's fixed.
Fantastic. So we've talked about some really huge initiatives the city's doing, some really long-term initiatives where the space will be available in 2028, 2029. I know our students and our faculty are impatient, especially when we talk about climate change. What are things that you're doing even now before some of the space is activated or some of the programming is launched that people can get involved in now? or in the next 6 to 12 months?
Yeah, I'm happy to jump in. So this year we launched our first cohort of climate tech fellows. This program is, think of it as a pre-accelerator. So in this first iteration was primarily focused on people emerging from our different university partners, perhaps from a postdoc program. We usually have one person who's still an undergrad at one of the CUNY campuses. We have execs in residence, scholars in residence, et cetera. But these are folks who have kind of maxed out what the university has to offer in terms of venture development support, and are now exploring how to get on the commercialization journey and how to start building their climate tech startup. So in this first cohort, we actually have an NYU team, someone from the FloodNet team who's been part of it with us, and we will be launching another iteration of that program. So if you're curious to learn more about the current cohort and kind of engage with them, we'll be doing a virtual showcase probably February of 2026, and then keep an eye out because we will be doing a call for additional applicants, and we'll be launching another program like that in 2026. A couple of other things we're doing, we do a lot around Climate Week, but we're also going to be doing a number of events around Earth Week. So last year we hosted our first Climate Solutions Summit. We'll be doing that sort of times 2 or 3 this year, so there'll definitely be opportunities, of course, to attend, but also to potentially propose if there's research or a project that you're keen to have shared with a wider forum of people. We'd love to hear from you around that as we kick off that planning process. And then very quickly, we are starting to do actual environmental data collection on the island. So we've established a modest observatory to start collecting that data to be used for different research projects. So if you feel you can benefit from access to that information, access to those data sets, get in touch, and vice versa. If you have instruments that you're keen to deploy and to actually start collecting more localized environmental data, our team would also be happy to talk to you about that. And last, we did a program last year, we'll do it again this year with NYCHA. So this is a program to provide microgrants and technical support to NYCHA residents who have ideas for climate projects they want to progress in their own housing developments, but we're definitely keen to pair them with technical support and kind of a broader network of people to get those projects off the ground. So that'll be happening again in 2026. And then if you really want to do something different, next week we are hosting a webinar on Tuesday. The information is on our website, all about the power of how we talk about climate. So the art of communications and the role of storytelling in reaching more people with information about the climate. So lots of different ways to engage.
I'll give 2 examples. One is we talked, or I shared a little bit earlier about pilots. So pilots at BAT is an active program. It's an opportunity for entrepreneurs to really figure out how their product performs in a very real world environment. But again, it's just this insane opportunity across everything from building decarbonization to multimodal logistics. And so I would encourage those, tell your friends, tell your sister, tell your brother, etc. For those folks who are in the entrepreneurial space in climate, it's applying for pilots. That is a great opportunity to really prove something. So you can Google pilots at that and get in the mix. So that's one opportunity. It's really, this campus is really fantastic testing bed for products and solutions in the climate economy. And the second is just, I would say, programming that we will be putting on over the next several months to really better listen and understand where we can be additive in the climate program here in New York City. I'll give an example based on what Austin just mentioned. We have a hunch that there's a there in maritime decarbonization for us, given that we are part of the working waterfront. And as I mentioned again, the Blue Highway Initiative to bring some of that goods logistics service movement on the waterfront to the Brooklyn Island Terminal. But we really want to have a good theory about how can we not be duplicative of others. Is it really more focused on workforce development? Is it really more focused on startup innovation? Is it really more focused on piloting? So in January, for example, we'll be having a listening session at the Brooklyn Island Terminal really about across multiple stakeholders, whether they be environmental justice groups, technology providers, and folks in the corporate side of logistics, of really what could be the unlock that we can provide in maritime decarbonization across startup incubation, piloting, and workforce development that could really help advance some of those programs, including the Blue Highway initiatives. So those are two ideas.
I've got a few for the students, faculty, and entrepreneurs who I think is the group that's in the audience. Well, first, come to our events. So we also have a bunch of events. You go to UFL.NYC, sign up for things that are always got a showcase or convening the ecosystem. It's a great way to get involved. But for NYU students in particular, we have an internship program. So over break, if you want to log into Handshake and search Future Labs, you'll find the Future Labs internship class. It's a three-grade class for sophomores, juniors, and seniors. And you can intern for a portfolio companies that will be posting jobs for next semester or overrun. And then another one too, if you're about to graduate, we do a quarterly jobs roundup of all of the companies that are hiring in our portfolio. So that will go out through our newsletter. I think the next one goes out right here, probably January, late January. Faculty, if you are, if you need an industry partner or startup for a grant or project you're working on, please reach out. You can look at our website and kind of see the different types of technologies we've supported in the past. But we've had some success where our companies will partner with faculty. They go out and grants together. It's a nice win-win because you get access to grant money you might not otherwise have access to because you're going with the business. The students get real-world, get to work on real-world projects, often get hired after they graduate, and then the company gets done with the teamwork. So I'm going to talk about that after try to connect the dots. And then finally, entrepreneurs just apply to our programs. We're going to have 4 different calls for startups next year across our programs. So we'll let you talk.
So 2 things I want to highlight. One, thank you for mentioning internships because it reminds me. We also have an internship program at UBC for the students in the room. This is the period that it's open, so please take a look at our website if you are interested in our agency. And then separately for faculty and entrepreneurs, one of the things that we have been thinking long and hard about in the past couple of years is how we can best ensure that when we create piloting opportunities, there is a follow-on opportunity that can come out of that, right? Is oftentimes talk of like pilot purgatory. And so we have been thinking about and innovating on a model called challenge-based procurement that enables us to really support companies who are delivering the types of outcomes that we're looking for in a pilot to secure a larger scale contract with us. And so we launched our first one at EPC. Given our asset management function, as I mentioned, we manage a lot of waterfront assets, and so one of the niche functions we have at EPC is conducting waterfront inspections. And so we are really interested in drones, robotics, computer vision, AI companies who can help us to explore much more innovative approaches to how we do our waterfront inspections right now. I don't think I can publicly say how poor it is right now, but it's a very normal process where it's happening. And so there's lots of opportunities for innovative candidates. There's, the private linkages are huge here, right? Like without our waterfronts, we're not able to be as resilient as the city as we manage, right? So that challenge-based procurement is up on our procurements page. We have our first info session for that next week. So if you are interested in this, it's an opportunity to have an engagement with a pilot, and based on the outcomes of that pilot, we research the right to actually expand the contract, which is surprisingly really new and really innovative.
Awesome. So, I hope you've learned about these organizations and what people are doing to support climate tech innovation in New York City. I'm going to open it up to audience questions for a few minutes, but right before I do that, I have a lightning round question. 1 sentence or less for each of you. Give us one quick example of a new development you've seen in climate tech that you're particularly excited about.
I'm really excited about innovations in bio-based materials and specifically applications in cement. There's a company called Prometheus Materials that does algae-based cement. There's a pilot live on Governor's Island right now of their material, and another company called Recycle that's spun out of Duke University and Pratt that's developing a bio-based enzymatic cement that we are exploring for coastal restoration efforts around Governor's Island.
This is going to be an panel on this in a little bit, but I'm excited about the climate adaptation sector. In our applications, it's growing 33% year over year, and those companies are generating twice as much revenue as our mitigation companies, so I think there's a really strong signal that there's a path to commercialization in the sector.
Well, lots of things. One company I've been thinking a lot about because whether they know it or not, they've been really instrumental to our thinking around challenge-based retirement is Edison, which is actually an acre company. They did a pilot with us at that and helped us to realize that we could save over $100,000 a year in energy bills if we were able to, because they were able to better segment what customers were not paying. And so it's not necessarily like the newest thing, but for EDC that was extremely new, and for EDC being able to sort of like quantify that value and realizing we could procure that of a like mind-blowing exercise for us.
A new development is, I think, in the last many months, many universities and folks who work in the energy sector have been frustrated by changes in political situations and funding situations from the federal government that have made lives different. There's a silver lining to that, which is if you're in the energy space and the climate space, there are very few states. So if the feds have said, hey, we're not going to be funding some of this stuff, there's very few states that really support this work. But in New York, California, Massachusetts, and so you are in one of the best positioned cities to be able to really build a startup and get funding for the state that really cares about continuing climate. So it's a new development that is a silver lining.
Great, thank you. I have a question here.
Hello, thank you for the wonderful panel. I had a question for, I guess anyone can answer, but Alex mentioned that there's very few states that support, the energy transition for the near coming future as federal funding has shrunk in that area. But a lot of these companies in New York, like 9DOT, for Urban Future Slot, still rely on community solar and other aspects to fund parts of their needs. They need energy sources to produce batteries and whatnot. So my question is, in the next 5 years, 5 to 10 years, how much of the energy transition is going to be localized? And how much of it do you think is still going to be federally led? And in addition to that, are there going to be certain climate technologies that are going to fall through the cracks because federal funding is going to shrink in places like New York City, not be a bubble for that long and continue to hold up a lot of these sectors like hydrogen or other technologies that might not be commercially available in the future?
Right.
Yeah, I think it's going to be localized in cases like energy storage. I mean, NYU's got contracts, I think, to do 9 different projects around the city, and they're discussing focusing on New York City first because I think it's a good example that can take it elsewhere. But it also lowers utility bills, it also lowers your component bills, and they set those up. So I think those financial realities, more and more required for more that is concerned. That's my personal way of being able to New York bubble. So we can't be confident outside our bubble.
Yeah, I mean, I would underscore that, like, at the city level, we know that, we're doing everything we can with our, like, NIDAP, for example, has really benefited from our discretionary tax incentives, our IEA. And so while we are bullish about making sure companies are aware of that and are utilizing that, we know that we can't necessarily fill all the gaps that are being leveraged by the federal administration. So we're hoping that the best. So
Yeah, and my personal question is, it's going to be lumpy for the next few years in cases where there's already a really strong market pull. Energy being a great example of that, specifically around anything that can be done to build sustainable data centers and sort of stabilizing grid, what we were talking about earlier, that will continue. I think there's just already market momentum and forces, but I personally worry about the very kind of top of the innovation pipeline. A lot of the more traditional non-dilutive funding and grant mechanisms are going to be smaller, more constrained in the next couple of years at least, and so I think things will get a little lumpy and stall out where there's not yet market demand, but I think the good news is some of the stuff has reached a tipping point and it kind of already makes sense, whether or not you want to talk about it in climate insurance.
Yeah, and then maybe the thing I would just say is I think there are some good precedents for moments in time where either city-led action across multiple cities or state-led action has been just really transformative. And to give one example, if you look at vehicle decarbonization in the US, I think it's safe to say that the California Research Board has been probably a lot more instrumental in some of the systemic changes in how we thought about vehicle emissions and how it's actually been deployed than the federal government. And so this is, I think, a really good moment for cities and states to not only think about individual action, city level or state level, but also collective action because, yeah, that's where the opportunity is for us.
Back.
Hey there. Is this microphone? Thank you, Jamie. Smash. Here we go.
Hi everyone, my name is Erin Leeds. I'm actually at the Urban Future Lab. I've met all of you in one shape or another. My question is actually specifically for Kensei. We have a new mayor coming into term in January. I'm curious what the EDC is looking forward to in working with Zoran Moldani and how the Green Plumbing Plan might be impacted, or I'm just curious what it's going to look like in this new mayoral term.
Yeah, so, you know, EDC has been around for 30 years and we have operated under many mayoral administrations. Part of EDC's sort of like secret sauce, magic sauce is our the breadth of tools that we have. And so, like, top line is that we are excited to be able to deploy the breadth of tools, whether it's the assets we manage, our $9 billion capital budget, the discretionary tax incentives, to be able to advance the priorities that Mumdani has been, Mayor-elect Mumdani has been elected on. And we also think that a lot of the work that we have been doing and have articulated through the Green Economy Action Plan is really aligned, right? Like, you know, like I said earlier, that the Green Economy Action Plan was really our vision for how we make sure that we're not just advancing our environmental and climate goals, but really ensuring that it creates economic opportunity for New Yorkers, right? Puts more money in the pockets of New Yorkers, right? And so I think there's a ton of alignment at that highest level.
And maybe just to add one thought, I do think for a campaign to focus a lot on affordability, it's not virtually for us in the climate space to really hone our messaging. We were just talking about 9 energy and others. Like, there are a lot of situations where we should be much more clear about the cost savings and affordability benefits of climate technology. And I think it's just going to have a lot of relevance improvements both in New York City and nationwide if we can get better at messaging as a climate community.
Great, I think we are at time now, and just, yes, and for, no, he's already got the microphone stand, fine. One more question.
Waiting for Ian to come. Hi, Prof. My name is Ed, and I met all of you also as well. And I have a little bit, Indy's going to be a little bit more critical, so maybe you should have updates. I teach my students about you build for those you have and those you want, right? And when we're thinking about the work that you're doing, I was trying to figure out a way to phrase this question. I'll shoot it and we'll see what happens. For all of your work, how are you balancing growth, or at least idea of growth, with community stewardship? And what mechanisms are you including in your work, whether it's with startups, whether it's with the community, other businesses, to allow or actually encourage local communities to be part of the decisions that are affected?
I was going to say, Alice, you was looking at the
Yeah, so in the front, at BabWorks, we have there's a mitigation discussion in about a week and a half. soliciting that input from the community about, again, sort of what in particular is wanted in terms of services that we'll be offering across workforce development, certification, modeling. On that topic as well, we've done a survey of local residents, over 100 folks, have given their input about what in Sunset Park people want to see happen, and doing a lot of outreach as well on a one-on-one basis. But I think that we also try to think about novel ways of doing that at a more systems level. One thing, Austin mentioned, NYU does not take equity in service, Lacey does. We take sweat equity in service in exchange for services. And the way we've sort of linked our startups with the direct community impact is by an impact framework. When startups leave the program at Lacey, they're eligible to earn up to half of their sweat equity back if they have met certain impact targets, including around community engagement. So that's the way we think we can incentivize startups at the very early stage to think about local community impact and how their work impacts communities.
Yeah, I think too, I think it's a fair prompt and something that we're sort of continuously asking ourselves as we start to design different programs. A session I missed today in order to be part of this panel is actually the module that we have for our climate tech fellows about how to embed equity into early stage venture development. So what does it mean to engage with communities? What's the right way to show up? How do you really think about that from the ground up, not at sort of a much later stage of your development? So we're quite literally trying to embed some of those principles and those mechanisms into how we teach and think about climate tech venture development. And then I don't know if it's public yet, but we are working closely with a number of our partners on a project that is very much starting from a place of community priorities around improving resilience of critical assets, and then leveraging, applying AI and new kind of modeling techniques to support pushing those things out. But it starts from a place of bringing the community to the table and figuring out what they want to prioritize, and then applying the technology in a more sort of surgical way versus starting with kind of what the AI model wants you to prioritize. So we're trying to experiment with it in different ways. Ongoing.
I'd say that this is something that EDC thinks a lot about and sort of like struggles internally with, and sometimes we are getting it right more than other times. I think navigating sort of our mandate to be a citywide, 5-borough focused agency with like the fact that so much of our work is place-based and like very specific sites, this comes up a lot. And a couple of things we try to do, we have the opportunity of really working with like large scale corporations and companies, right? We work with Equinor on offshore wind, we're working with Emanate on medium heavy EV charging in Hunts Point. And so when we are negotiating our leases with those types of entities, we really try to focus on what are the MWBE requirements, how much can we try to localize workforce hiring as much as possible. There's a lot of kind of legal barriers around how far we can go, but we're constantly trying to kind of push the envelope and do that.
My name is Lorenz, but we have an event series called Climate as an Economy and another series called the Future Forum, which are specifically set up to kind of break down those walls and talk about how to engage with the community before you're going to this is sort of shallow, maybe immediately start to work with companies. So those are two forums that we use, and I think on our startup selection side, we built it into our evaluation criteria that anyone we take in has to have at scale a positive impact on all the groups and communities. So I think those are two examples of how we're looking at it.
Hi everyone, thank you for coming back. I hope we could just bring the cheese board, but hopefully we can all get the people from the side too. So it's great to have Jamie Torres-Springer, and he is a president of MTA Construction and Development. He's responsible for better, faster, and cheaper delivery of MTA's $55 billion capital plans for innovative management of construction work for subways, buses, commuter railroads, bridges, and tunnels. Prior to MTA, he was commissioner of New York City's Department of Design and Construction. So we have already some delay. So without further ado, the floor is yours. Jamie, thank you so much for joining us today.
Great. Thank you. Let's get this. You can see what I look like. So here we go. And let's see if this clicker works. Because there we go. Okay, good. So this is a. No. How about that? Now? All right. This is a little less awkward than standing way back there. Good to be with you all. This is a great set of sessions, and I found my way into infrastructure delivery and planning and building and coordination really through climate work after Sandy, including there's a couple of people here that I've worked very closely with for years. Edgar, Alan from DP is here, probably a few others. Lots of people have been contributing to this stuff for a very long time, so it's a big part of what we do, but not always my focus, running the whole agency like this, so I'm very excited to get a chance to just give you a little bit of an overview. And I'm going to try to do it fast. I don't know if you're trying to get back on schedule or not. You asked me to take 45 minutes. I'll try to do this in 15 or 20 minutes if I can, and then hopefully we can have a bit of a conversation, because that's probably more interesting. So, the overview, the good thing about the MTA is everybody knows the system and what it's comprised of. But just to be clear, we have 5 agencies at the MTA. There's New York City Transit, which is responsible for the subway system and the buses. And then we have 2 commuter railroads, Metro North and Long Island Railroad, and the Bridges and Tunnels Agency. That's famously the old Tri-Road Bridge and Tunnel Authority created by Robert Moses that was absorbed into the MTA over the years. 7 bridges, 2 tunnels. And then we have a 5th agency that I run, which is responsible for construction and a number of other things, and I'll come back to that. But you all know that the simple way to put all this is there is no New York without transit, and it has all of these benefits, including affordability and unlocking the potential for growth. But we're here talking about climate, and there's a lot of different ways of thinking about this, but the reality is in our region, we certainly have by far the lowest greenhouse gas emissions per capita in the United States, and it's because of the MTA. So clearly, it's important to keep this system running. And we always sort of like to emphasize this, that while there's no New York without transit, there's no transit without sustained capital investment in the right priorities. And you can sort of see when we did our needs assessment and our new capital plan, we tried to put out sort of the competing visions of the future of our system and what it can be. And we were fortunate enough to get fully funded by the state legislature. I'll come back to that in a second, but really because everybody, kind of bought into and adopted this vision of not only implementing congestion pricing on the streets, which we've done, and we're about to hit our 1-year anniversary of that next month, but also investing in the state of the repair and investing in improvement in the system so that we can keep having a great transit system. I know everybody's got a lot of individual complaints, right? This floor is dirty, I tried to have my card and it didn't work, but in general, you can sort of it's just the miracle of the transit system. I often say, really privately, which I think is where we are, that to sort of the outsider, when a train is delayed by a couple of minutes, it's sort of outrageous and everybody's sighing and expressing irritation. When you work at the MTA, it's like when a train pulls into the station, it's sort of a miracle. all the different things that have to happen for that train to actually pull into that station. It's really extraordinary. But we're investing in it and keeping it going. And as I mentioned, we created a separate agency. That's not the focus of this conversation, but just to give you a sense, we created a separate agency because we wanted to deliver the capital work better, faster, and cheaper, and plan for the future in a very strategic way, and also build a sustainable organization that will be able to maintain that investment. And we've really done that. And again, I'm not going to focus on this, but the way we do it is we're responsible for the whole capital program from beginning to end. We do a 20-year needs assessment every 5 years. That's mandated by the legislature. And then we put together a capital plan that's based on that. It's about mostly bringing the assets into a state of good repair, but identifying what the priorities are for improvements to the system and build out of the system. More on that in a second. Then, after planning, we think very strategically about how to deliver a project. Again, not the focus of this conversation, but things like alternative delivery models, using contracts more effectively, being strategic about how we bundle projects together, right? And then again, I should move on, but when you look at all the station work that we're doing, we made this commitment to make 95% of our stations ADA accessible by 2055. Well, we're now doing that at 4 times the pace than we were in the past, because we're bundling them together in multiple contracts to take advantage of economies of geography and economies of scale. And so, we're able to do that because we also control all the contracting, and then we're building an amazing delivery organization that is, laser focused on delivering things on time and on budget, all supported by a lot of management capacity. So that's what we're doing at C&D, and it's paying off. We've identified $3 billion that we've saved since 2020 by thinking more strategically about what we're building, being careful about scope. The sort of contracting benefits that I talked about, it means that when we get bids in, they're substantially below what we think they're going to be at, so we can look at that as a savings. We save money on what it takes to actually deliver a project, and then some of our insurance and other support systems have come in a lot cheaper. And all of this money, we just actually did this at the board meeting a couple months ago. It was approved by some key leadership in Albany just in the last couple days. We've put all that money back into getting more done within our system, and so that really shows you that it's paying off what we're doing. Because of all that, you have a correction to make to my bio. You talked about a $55 billion plan. That was our 2020 to 2024 plan. In the spring, we got our 25 to 29 plan approved, and it's $68 billion. And that was a recognition by the state legislature, a lot of other folks, that we were getting things done in a highly value creation sort of way. And I'm not going to talk about the whole capital plan, but it's got some important things in each of these categories. Frequent and reliable service, a lot of that is about state of good repair, and it's about taking we have 6 million different assets in the MTA system, and we're bringing them slowly into state of good repair after decades of neglect. And it's things like power, structures, overhead rail, the track itself. We're ordering 1,500 new subway cars over the next couple of years. All of that is what it takes to bring a system to state of good repair and operate service reliably and frequently. Also, adding service. So the Second Avenue Subway Phase 2 is under construction. And I know everybody's excited about this. The Interborough Express, which will be our first light rail project. We're fully into design and environmental review on that project. We had some scoping meetings the last couple of weeks that went pretty well out in the neighborhood. So that's an exciting project for service. Very focused on improving the customer experience, and that includes making those stations ADA accessible. Elevators aren't just for people with disabilities, but they're a huge convenience. And also, I've been responsible for the full implementation of Tap and Go, which I'm assuming everybody, we're now 92% adoption. And MetroCard is sunsetting at the end of this year, so we'll soon be at 100%. And we have a great app, and we have great information, we have great signaling. All of that stuff is getting done as part of this plan. And then we're taking action on climate change, and that's what I want to talk to you about today for a few minutes. So I looked at the website of the Sustainable Engineering Initiative, and I really like the framework that, it's one that I think we all know, but it's actually a very great way to look at it. This AMRAD, right? Avoidance, mitigation, remediation, and adaptation. It sort of stimulated amongst my climate team. We said, we got to think a little more about remediation. So I don't have anything to talk about on remediation today, but I want to take you through how we're working on these other areas, and I'll just shift over here. So first of all, avoidance. I was alluding to this before, but we did an assessment, and because the MTA exists and carries about 6 million passengers a day across all of our modes these days, we enable our region to avoid in total 22 million tons of carbon emissions a year, which is the reason that, right, our region has a low GHG, per capita number. And that's through, we can get into all the details about why that is, but it's through, through avoidance of direct emissions and avoidance of indirect emissions. But what we also assess is that we emit in the course of our activities 2 million tons a year. So our 22 drops to a net of 20 million avoided tons. But that's a really important way of looking at the avoidance formula because, I'll be honest, I have a slightly different role than all of you, right? I have to make these difficult investment decisions. And if somebody says, well, we should spend more money reducing that 2 million tons of carbon emissions every year, I have to look at how we're going to pay for that. And for example, if it means a fare increase that takes people off of transit, then we're going to lose some of the 20 million avoided tons. Does that make sense? Or the 22 million avoided tons. So that's the real investment calculation, in the world of a public agency like this, where we are focused on this shared goal, but we have to think about it a little bit different from an investment perspective. That's really important, but that's our avoidance story. And then we are doing lots of mitigation, and I caught a little bit of the last panel. There's lots of interesting stuff going on, despite all the, the sort of retrenchment that we're going to see in DC for the next few years. If you just look at our picture, you can see what's our direct emissions and our indirect emissions. But basically about 50% of our emissions comes from power in our trains, traction power on the subways, and the commuter rail lines, plus the diesel for some of the non-electrified commuter lines. And then another quarter is our facilities and the operations of those facilities. We have, I forget what it is, I think 400 or 500 acres across the city. And I forget how many built square feet at the moment, but we have a huge footprint to operate the subway system. And it's obviously using power to do that. And the last quarter is the operation of our bus fleet. We have 6,800 buses on the streets. They are running some of the most difficult, complicated routes in the world. And they largely are still burning diesel, although they're doing it in a way that's 97% cleaner than it was 25 years ago, which is a good thing. And then we have a lot of non-revenue vehicles as well, but that's the general picture of our emissions. So what are we doing about this? We're working on all the different aspects of this. I will say that our electricity supply is sort of an indirect thing where the state has made a commitment to move to renewables over time. So we look at that as a sort of indirect thing where we'll be shifting to renewables, but we made a commitment, it's just at the top. We made a commitment a couple of years ago that we're going to get to 85% reduction in that 2 million tons of carbon by 2040. So how are we going to do that? First of all, updating our facilities, lots of stuff going on here. The thing that's important, and I think everybody knows this from all the work that you're doing, this is a sort of principle that Alan and I learned back in the days of post-Sandy coming up with this $20 billion plan to make New York resilient. If you just try to rip everything out and improve it and turn it into a sort of no emissions asset all at the same time, you're never going to be able to afford to do any of it. What's important when we're making these investments over long periods of time is invest incrementally. So as we replace these very old boilers that we have all in the shops all over our system, we're looking at alternative technologies, including ground source heat pumps for the purposes of that replacement. We're not going to do it all at once, but we're looking right now at doing it at 3 subway shops, and that will have an enormous effect. The key for us is putting these design guidelines and these specifications in place so that when we do that purchasing, we're doing it with something that doesn't produce significant emissions. So we're updating a lot of facilities. I could spend a lot of time on that. Of course, we're doing a little bit of on-site renewables, and I don't have anything on that, but that's important. We are transitioning our bus fleet to zero emissions. The commitment that we made a few years back is that we will also do that by 2040. In this new capital plan, we have 500 zero-emission buses, but I will tell you, this is very tough in the city. We're at about, I believe we have about 60 or 80 zero-emission buses today that are on the property, meaning they're in our system. And we have a couple big challenges with that. One is, we have a lot of Buy America requirements, and we have a lot of state requirements to purchase. Domestically, we really only have one electric bus manufacturer left that we can buy from in New York State. Then the second challenge is that operating electric buses is not an easy thing in a system like ours, where the routes are very long, the streets are almost never in good condition, they take a real beating, and we're having a lot of trouble actually integrating those buses into our fleet. So it's going a little slower than we would like it to do. The other thing from a capital perspective is that these buses all charge, today they fuel, they have to charge in future at bus depots, of which we have about 30 all around the city. A lot of them are 50, 80, 100 years old. In some cases, the roof isn't high enough to install a pantograph on top. And we're looking at plugins and we're looking at induction technology, but we also don't have anywhere near the power supply that we need in order to do it at those bus depots. So my point is, we're doing all this, we're committed to it, but it's a gradual transition and it is grueling to get this done. But the fact is that for what we can reduce out of that 85%, about 50% of it is going to come from transitioning to the zero-emission bus fleet. We're looking today at, whether there's, I think actually we just placed an order to do some more hybrid buses, just because as we transition, we have to figure out how to do this, but we still have to, again, 20 million tons avoided because we're carrying people around, so we got to make sure we still are able to run good service. An example of where we're investing is we're almost done with rebuilding the Jamaica Bus Depot. This is a community, certainly a great candidate, recipient for environmental justice benefits. So this is our first all-electric bus depot. It's under construction. It's going to be home to 275 buses. We're going to get the charging up as we go. Lots of complexity here. Con Ed has to build a new substation in Jamaica in order to support this bus depot. We supported that in a rate case. They're doing it, but that's going to take a while. We also made the decision that we need to move to high voltage charging in this bus depot, so we have to really change over all of the charging equipment in it. And then of course we have to get the buses, and we have to get the chargers, and we have to figure out what kind of chargers work. So this is all underway right now, but it's very complicated. The last thing about mitigation, I mentioned a lot of traction power, lots of interesting stuff going on here. We obviously see a lot of regenerative braking technology being used in private vehicles. We have regenerative braking technology in all our new subway cars that we purchase, but because there's not enough to power on the vehicles, we can only use 12 to 14% of power generated from regenerative braking on the cars. So we're looking at and we're piloting other methods to make use of regenerative braking energy. One idea, which we actually already have working on the Metro North New Haven line, is a reversible substation. We have 280 substations in our system. Most of them, the majority of the components are 50 years old, so which I say it's very complicated. We're investing $3 billion over the next 5 years in that. And one of the things we're looking at is there an opportunity to buy equipment that makes it reversible, meaning we can, instead of powering traction power on the third rail, we take it back through regenerative braking and then are able to put it back into the grid, or we're also piloting battery storage. So pretty new, but we think there's a lot of opportunity there. On the adaptation side, we've spent a lot of time on this. We released a climate resilience roadmap in 2024, and this has been the basis for how we're proceeding on all of this stuff. I'll give you a few highlights here. I see there's a lot of climate scientists in the room, so if I try to say this right, I'll get it slightly wrong, but in my head, just very simple. I should mention, we created a climate planning division when I arrived at the MTA. Some of you know some of the folks that run that division, work in that division. We've done a multi-hazard vulnerability assessment. So we looked at, for reasons I'll talk about, we had a pretty good sense of coastal flood risk. but we've added torrential rain, heat waves, sea level rise, and a few other hazards. So we've taken projections of hazards currently and in the future, looked at them in reference to exposure within the assets and the systems that we have. Again, we have 6 million assets in the MTA system. Obviously, net out projections that we've completed, and that shows us what our climate vulnerability is. Somebody can argue with me about whether this equation makes sense or not. I actually turned the plus into a multiplied sign as I was coming over here to that I'm side. So, as I said, we've looked at these 4 hazards, and everybody knows this. I don't need to get into this, but we are facing increases in the levels of those hazards. Coastal floods 3 times more likely, 30 inches of sea level rise, lots of torrential rainfall events, and obviously New York City will feel more like Birmingham, Alabama in 2 or 3 decades, and that has really significant impacts because we all know that it's hard to remember on a day like today, but it gets pretty hot in the subway stations in the summer. So coastal risk is very interesting because we had this huge event. I know it's sort of in some ways beyond the time horizon for a lot of people sitting in this room, but it was very formative in this region. It was the first time everybody really focused on, risk from extreme weather. It did $4 billion of damage to the MTA system because of significant amounts of coastal flooding, and that's the sort of negative part of it. The good part is that the federal government acted. Sandy happened in October of 2012. In January of 2013, the federal government appropriated $55 billion for recovery, and the Obama administration at that time made a huge set of policy changes to encourage resiliency as part of those rebuilding processes. So it gets very complicated what you're able to use the dollars for, but the MTA, and I wasn't there for most of it, but the MTA was very entrepreneurial, had a lot of plans in a drawer. This is so important. Pulled those plans out, and we have managed to use $8 billion of that $55 billion appropriated actually for the whole country. I think Edgar Allen and I were involved in different ways of getting a few dollars here and there to other parts of the country out of that. But we were able to use $8 billion to get all of this work done, but only in places that were damaged and had coastal vulnerability. So there's tons of examples we can talk about. You can see some of these things all around the system, the way we've hardened subway entrances and enclosures and things like that. Some of the large-scale things that are really interesting is we have a couple dozen train yards all across the city. They're mostly in the Bronx and in southern Brooklyn and parts of Queens, or central Brooklyn and parts of Queens. And most of them, like a lot of infrastructure, built in low-lying areas on the water's edge, right? Because that's what, back in the day, that was the unattractive property. That's where you put things like this. And so they're very vulnerable. So we've just finished multi-$100 million flood wall. You can see it being built at 207th Street Yard in the Bronx. It's actually amazing. Of course, when you do this, you have to avoid the bathtub effect of trapping the water in if you have heavy rainfall coinciding with a coastal storm. So we rebuilt all the drainage. We actually moved some of the drainage out of the yard so that we wouldn't get overwhelmed by rainfall draining from other parts of the neighborhood. We've also done an amazing thing. Coney Island Yard is the largest rail yard in North America. We built a similarly, a structured flood wall all around Coney Island Yard, rebuilt all the drainage, and lifted all of our power supply up onto bridges that run over the yard with cables hanging down to connect to the third rail. And actually now we are in the midst of improving a lot of signals in the yard, and we're pulling all of the signal cable up into those overhead bridges as well. It's a really amazing project, but we're able to do that with federal standing money. Another thing that we are, this is the Coney Island Yard elevated cable bridge, and the wall is behind us in this picture. We also have been able to invest in the Rockaways. We did a long-term shutdown on service of the Rockaways last year because we needed to repair and harden that swing bridge that sits in the middle of Jamaica Bay. And we fully rebuilt what's called the Hamels Y, which is the viaduct that brings a service onto the Rockaway Peninsula. But we did it with Sandy funding, and we did it in such a way that it's much more resilient because we lost service for 8 or 9 months to the Rockaways after Sandy. So coastal, I guess my point is coastal investment, we got that federal money, we were able to make that investment, and we know where some of our lingering vulnerabilities are. Here's the thing that we've realized in the last few years, there's sort of pluses and minuses of coastal risk versus heavy rainfall flooding, but from our perspective, coastal surge, it's more corrosive because it brings salt water, but it is slow moving and much more predictable. You know a few days in advance, you can deploy sort of active mitigations like gates that are deployable because you have time to deploy them. We have a whole operation at the MTA for deploying these protections. Heavy rainfall is the opposite situation. It's less corrosive because it's rainwater and not salt water generally, but it's fast moving and you don't really know where it's coming. And also happens a lot more frequently. These days, really, twice a year, as I'll talk about in a minute. So you need passive mitigations. You can't get out there and deal with everything. So this is what we're reckoning with now, and we don't have federal money. So we have to figure this out on our own. Here's the sort of work that we've done. We've seen that on average there have been 2 storms every year in the last 20 years that have been brought more than 1.75 inches of precipitation per hour. Why am I using that number? Because that is roughly what a city stormwater management system is sized to. So beyond that, water floods all over the place, including into our system. Because of that, in 200 subway stations, we've had impacts from heavy rainfall flooding since 2007. You can see we've studied it, we've identified where those vulnerabilities are. And look, this is a complicated question, and everybody here knows, you get the YouTube videos, the social media videos of water pouring into the station, right? And that's no good, that's totally unacceptable. The reality is, unless the water is above the 3rd rail, or the station is really impassable, you can still run service. So what we're trying to do is we recognize that there are going to be these very significant storms. You're going to get water, the station, 63% of the subway system is underground. You're going to get water into the system. We've got to figure out ways to make sure that we can keep running service and that passengers can be safe. That's our focus and our priority. And of course, we can talk about this for a while, but the sort of basics of how the water flows is you have you have significant amounts of flooding. Clogged catch basins mean that the water can't get into the city's sewer system. We have a lot of places where we have what we call low curb reveal, which means that over time, as city DOT has paved up the streets, and some of the what's called the hardware, right, the manholes and things like that, get built up. There isn't enough room between the roadbed and the curb for water to be stored during those heavy rainfall events. So if it gets up onto the sidewalk, then it gets 3 and 4. It gets into our street vents, which are our 100-year-old system. We don't have mechanical street vents, and it gets down into our entrances. And then of course, the fact that the city has constrained sewer capacity in general means that we can't move. We pump 13 million gallons of water out of our system on a dry day. Groundwater. So we have a lot of pumping systems, but if the pumps can't send the water anywhere because the city sewer is overwhelmed, then the water stays there. So that's really the risk from heavy rainfall. What are we doing? The solution is the solution is everywhere: dry proof, wet proof, right? We're trying to keep stormwater out by investing in some cases, you can just raise the top stair of an entrance. We can raise vents, we can institute vent covers, but it's hard to know when a storm is coming, so that's not always all that effective. But we're installing protections like that. Also, we have a great task force with TDP and DOT that's doing the tactical stuff of cleaning out the catch basins, adding capacity in certain places. I'll be perfectly honest here, we haven't made that much progress on this curb reveal issue, and we really would like the city to make progress on that. As well as to build out more of its stormwater infrastructure so that it can contain more water. But lots of progress being made. And then we need to be able to build up our pumping system so we can remove stormwater that does get into the system. And we're making a major investment in pumping as we do that. Of course, same thing with our open cut railroad infrastructure. So in this climate, in this 25 to 29 capital plan that I described, we have $1.5 billion for investment in heavy rainfall resilience specifically, $700 million. This is going to get us to investments in about 110 stations, top step, vent covers, other improvements that keep the water out or allow us to improve pumping capacity. And then our other major vulnerability is up in the Metro North system. The Hudson line is sitting along the Hudson River, which everybody knows is tidal. So, significant flooding issues there. And also you can see a major mudslide that we had up in a place called Scarborough along the Hudson line a couple of years back. So you have a real confluence of risks there. And we're, I think, out in the market right now to start designing improvements to the Hudson line so that we can make it much more resilient. We've got $800 million for it. Last thing, extreme heat. Lots more we can talk about here. This is tough in our system. We don't have a system. You can't, nobody has. You can't implement full height platform screen doors. It's infeasible at 75% of our stations because of the load that the platform screen doors will bring, or because it would, because our platforms are so narrow, we wouldn't be able to have ADA accessibility. The other 25%, it would be prohibitively costly to do it. So we're going to always have that piston effect of trains moving in and out of the system. Some of that regenerative braking will be effective, but we have to find other ways to cool the station. And it's about customer comfort and safety, but it's also about all the systems. As we build out this system, we have more and more sophisticated equipment that needs to be cooled in the stations. So we have to figure out a way to act on this. We have an RFI out right now on geothermal cooling, which we see as an opportunity. I think probably people here know more about this than I do. But we've seen this deployed in buildings, all over the place, but never in a subway system, so far as we can tell. So we're looking for an opportunity to do that. We have a couple pilots going where we're basically looking at heat recapture within stations. We're actually going to pilot a technology in the East Broadway station on the F in the next year or so. And then up in our railroads, we're looking at white rails, and we found that painting the rails white, which is a big issue. Overheating of rails generates buckling of rails. We found so far we've been able to cool rails down by 12 to 14 degrees in these high heat days. So lots of opportunity to deal with extreme heat, but it's going to be a gradual, incremental thing in a system like ours. I think that's it. We have a lot going on. Hopefully I left enough time that we can have a conversation.
I think we have time for questions.
Great.
So you talked about how part of your emissions are coming from like diesel locomotives and stuff like that. Are there any plans to electrify the commuter railroad? Like 100% electrified railroads?
What was the last thing you said?
Are there any plans to completely electrify railroads?
Well, the railroad, actually the numbers in the state in my head, but our railroads are substantially electrified. We definitely have the most electrified track miles of railroad in the country. And we are looking at opportunities for that. We actually have, as part of this same plan that I'm talking about, we have some funding available for capacity expansion on the railroads, and electrification is often the right tool for that, but it's not the only tool. And it's just, I think what we did in putting together our plan was to create a cost-benefit tool that we can look at for electrification. From a climate point of view, it's a no-brainer, but in terms of what's the benefit to service, and also what does it need to use resources that would be used for electrification for something else that might generate more climate benefits or more service benefits, again, to increase that 20 million tons. So it's a complicated issue. So no capital project. Actually, there is one track that we're electrifying on Metro North territory right now, but we're studying a few other opportunities.
Question. Great talk, thank you. Two brief questions. One, I understand that the MTA is suffering from a lot of obsolete hardware and electronic equipment, signal systems. what have you done to improve these new installations? So it seems like there's a lot of work happening now, but you have the same problem 50 years to get. And then second, what can, you as academics or startups, if you had a startup goal,
Yeah, great question. So technology is complicated in our system. I think we're focused, it's hard sometimes. What I would say in response is the most important thing is to focus on the backbone and not just the devices that customers interface with. So, one very good example of that is we have a public-private partnership. We're getting fiber installed throughout our whole system. It is very tough. It's going to take 10 years. But so far, we've got the shuttle lit up. And anybody who uses a Draw 2, 405 from Rural Hall to Bowling Green, and you have AT&T service, that is lit up. T-Mobile is acting at their board meeting this month to invest in it, and Verizon doesn't seem to be playing ball, so if anybody has a Verizon phone, go ahead and let them know that you're keeping the service. Depends on them participating. You're laughing, but actually, this makes a big difference to the carriers when they hear from people, honestly. But that's customer service. They'll actually pull strands for us to use. So we're focusing on the backbone, and then we're just trying to keep ahead of technology. Signals is a whole other presentation, but I will say that we have evolved. CBTC is a technology that we started deploying in our system, the Canarsie line and Flushing line 20 years ago, but the way we were deploying it did set us up for obsolescence in terms of actually rebuilding a full set of redundant conventional signals along with replacing the signals with CBTC. What we've moved to actually with the crosstown line, which is not far from here, the G line, is we're doing what's called CBTC centric. And it's in the lingo of CBTC, it's step 2, and step 3 is the most aggressive. But in this case, on the crosstown line, we are only rebuilding computer-based stream control. And we're doing it with much less equipment deployed on the wayside. It's mostly car-borne, and then a more minimal amount of equipment in the tunnels, so it'll be much easier to replace and manage, and it's much better technology. We actually, again, I can go on about this for hours, but on the Queens Boulevard line east, which is the eastern part of some transit nerd here is going to correct me a bit. The MER in Queens, it's the last one that we did before adopting that approach, and we're a couple of years behind installing it because our contractor can't find engineers who can create a book of plans for the conventional signals that we're trying to replace. They just don't exist. I think they found them now, but that's holding us up. So we're totally committed to technology that is highly flexible. Tap and go is the other example. And we sort of leapt ahead by a couple generations, and we're thinking hard about it. We didn't talk a lot about our planning division, but we're about to start thinking about how are we going to collect fares 20 or 30 years from now to try and stay ahead of it. But it's an important point, very important. What can academics do? Lots of stuff. I'm sure this is very rich for lots of people to take a look at, evaluate what we're doing. Is it the right thing to do? What are the risks? We also have a partnership with the Partnership for New York City, with what's called the Transit Tech Lab Challenge. And so every year we come up with a couple of challenges, and then we get startups to come in. Cascara that I mentioned, which is the heat recovery that we're going to pilot at East Broadway Station, is an example of that. We did a climate challenge a couple of years ago, so we're trying to create a lot of room for startups to come in, and very open to innovation and opportunities of change.
Here. That's right.
Jeremy. Hi. So my question, on top of other people's comment, is glad that you guys are looking into further electrifying the Bigger Rail, most notably LWR, further east around Kankama. But one of my colleagues did a study this year, Momentum, detailing the population densities around Long Island counties, and we found out that the density is much more heavier around the South Shore portion of the lines, and also there are much better benefits with electrified rolling stock on the Oyster Bay Bridge. And are you looking into these alternatives versus further electrifying the main line east along Concoma as one of some of the options you're looking for? And my second question is, you're talking about IBX as an LRT, light rail vehicle, and I'm sure that there's a lot of comments already on high floors and higher power tractions. And would the climate side for better power of LRT push you towards, DC 1500 instead of DC 750? So these are two little questions. I don't mind if you just answer one.
So we're looking, so again, we just awarded a major design contract for the Interborough Express, and we have a team that's working on that. They're looking right now at what substation technology capacity is right for this program. The technology has evolved, and there's actually a lot, it's like, what I'm told, it's not my area of expertise, is that DC 1500, you wouldn't even be able to talk about it 10 years ago, but now it's an active analysis for us. We're always, the electrification stuff, like, we're always looking at these opportunities. I mean, population density is not the only driver, right? It's, are there alternative modes? What is the model show us? And it's all in that cost benefit equation. The good thing is we created this model and we ran it on a bunch of different, sections of line, which is how, as you clearly, our character very intuitive know that we're looking at top of the gap.
Thank you very much for joining today. It's been very exciting. I'm particularly very excited for this panel as well, as I do a lot of adaptation work. So I'm Meagan Mauter. I'm an assistant professor at NYU Tandon in mechanical engineering and also urban science. And today I'm joined with a wonderful panel. And maybe I can just briefly introduce everyone, and then I will let everyone talk a little bit more about what they are doing around the adaptation side. So we have Haley. And she's a climate science advisor at the Mayor's Office of Climate and Environmental Justice. And Haley leads multi-hazard climate science integration across New York City's urban planning efforts, including MPCC, where I work with her. And next we have Edgar. Edgar Westerhoff. He's Vice President and U.S. Director of Climate Adaptation at Arcadis Engineering Consulting Firm. And Edgar leads major coastal stormwater and also key adaptation projects across the U.S., bringing global engineering and delivery experience on cities and implementing our state resilient infrastructure. And we are also joined with Brian Hendrickson Smith. She's the Vice President in Morgan Stanley's Global Sustainability Office. Brian focuses on integrating climate and also managed risk data into sustainable finance and also risk management. And we have Alan Wolf. He's a Senior Policy Science Advisor at the New York City Department of Environmental Protection. Alan has long been a central figure in the city's stormwater and water management resilience work, bridging technical policy and operational planning for different types of hazards related to water. And then lastly, we have Julio Estrada. He's a finance professional specializing in climate risk and also resilience. Thank you very much for joining all. So the first question I have is not really a question actually, to briefly introduce your role, your organization, if you can, and how you work next to climate adaptation. Maybe we can start from you.
Sure. So I'm the climate science advisor at the Mayor's Office, and I work on the adaptation strategies team. So the Mayor's Office plays a lot of important coordinating roles when it comes to climate adaptation. We release the city's Plan YC, so that's our long-term sustainability and resilience plan that really lays out our core objectives across agencies working on climate. We also convened the New York City Panel on Climate Change, which is an independent body of scientists that assesses the impacts of climate change on the city and the region. So that feeds right into our goals in Plan YC. And we work across over a dozen city agencies that touch climate issues across city government.
The mic is live.
Yes.
First of all, compliments to everyone here in the audience on Friday afternoon as a student. When I was a student many years ago, the particular place was Stanford. No, very good here. So my role, I'm a director for climate adaptation with Arcadis. Arcadis is a large engineering firm. We do it all, roads, mobility, water, environmental works, and resilience is a big piece there to that. Resilience sits in everything, so as a resilience lead for Arcadis in North America, I'm involved in everything that the company is doing to adapt to our changing climate. The emphasis of our work for myself sits largely around the East Coast, where we have a lot of storm surge, a lot of storm activity, but active throughout the US and spent quite a bit of time in all our major cities. Of course, New York City is a fantastic, welcoming city and still leading the way in many ways as it comes to climate resilience.
Hey, I work at Morgan Stanley in the Global Sustainability Office, and we oversee kind of anything sustainability related at Morgan Stanley, which can be a whole bunch of things, but my personal work is in the data analytics team, and I work on what we call in finance physical risk data, right? So that's like impacts from climate, weather, things like that, and even spatial data, the spatial data analytics. So I come from a science background. I'm still learning all the finance piece, to be honest with you, and it's kind of interesting to see we work with people trying to construct like portfolios to invest in and take care of physical risk and work on the bank's physical risk. I'm sure you could probably tell you a lot more about than I can, and anything from that nature. So yeah, nice to be here with everyone doing kind of more hands-on stuff than me, but different perspective.
Hi, Alan Cohen with New York City Department of Environmental Protection. We are a water, stormwater, and wastewater utility. We handle all three for New York City, and in the last couple of years, we've also incorporated Bureau of Coastal Resilience. So we are managing all cycles, all parts of the water cycle when it comes to sea level rise, drought, stormwater flooding that you just heard about. So that has been my focus over the years. I also work with the cities across the U.S. as the current chair of the Water Utility Climate Alliance. There are 12 utilities, including desert cities, so facing very different types of risks, but very similar questions and approaches actually in some ways to how we tackle them. Yeah, I think I'll go to that.
Thanks very much. I'm Julio Restado. I'm here in my personal capacity as a non-expert kind of here, but I also have a climate science background. Brad and I went to work fast together focusing on hydrology, and I've had experiences in consulting for multilateral development or institutions around quantifying drought and bringing relief to locations in emerging countries. Similarly, quantifying climate risk for asset management and investments, and also working at climate expert. So I'm trying to bring together kind of from that range of experiences today.
Heather wants to make voice.
Great, thank you very much. So as you see, we have a variety of backgrounds, and then I think today's goal is really to see how cities are getting rich, and then how cities are getting presented in the tree. So I'm really excited to hear the different sectors' perspective here. So the first questions I wanted to ask everyone is, what does really climate adaptation mean in your sector or your field. And if you have like any prioritizing hazard or particular point, I would like to hear that.
Should we start or reversal?
Hey. I would say, I mean, from the asset management side, the main focus so far has been direct averages to specific assets, whether it's real estate or infrastructure. So, whatever costs is most averages, meaning tropical cyclones, wildfires, flooding, what we basically heard in the previous Keynote speech. As we advance on those, we start going to other sort of hazards as well, including things like heat stress and air quality. The main focus initially is on the big perils that cause direct damages and subsequent questions around insurance and insurability, risk transfer.
So for water management, climate is central. Too little or too much water is really a question mark, and we can't just plan for one because at any point, you could always be getting more and more rainfall, and we have to pump out against more and more sea level, air sea levels. We can have a flash drought at any moment, like we did last year, and maybe next time we don't get rain events to break it. So assuming we're in a multi-year drought, so we really do have to think about multi-hazard planning. We also have to protect our assets from storm surge, wastewater treatment plants that were flooded during Superstorm Sandy. We have to keep water out of the streets and subways, like you heard about before. So it's a really big task, especially when you're looking at citywide flood protection for extreme rain events. That is probably the biggest challenge we're facing today.
I think 2025 adaptation became like a major buzzword in kind of the finance world. Probably for some bad reasons, because people are seeing this as inevitable. We're going to have to deal with it, and we're not stopping it completely at this point. And possibly for some good reasons as well, right? People want to be proactive. I think what adaptation is incredibly poorly defined, right? Because adaptation could mean like, I was wondering about like in France they realized that just like knocking on your neighbor's door when there's a heat wave is actually the best way to save people's lives, right? But there's nothing money related to that. They can do it in major infrastructure projects, and so I think that we see it in a bunch of ways. One is research us to think of like what stocks should you invest in, who are like the winners of adaptation, which is kind of simple probably. And then we think about like from a real estate investment perspective, if you're investing in real estate, we saw that LA wildfires scraped up last year. We can have like major losses. How can we protect investments? And then there's also, should I just not invest in this at all? Groups to lead those, right? And so everyone's talking about it. I don't know that there's like a clear idea or main way it's being approached at this point, other than knowing it's important, it's coming, we've got to figure this out.
Yeah, I mean, being a water engineer trained in the Netherlands, I remember when I was graduating, it was all about good housekeeping, right? That was the Dutch, maintaining your assets. But the conversation has changed completely. Adaptation is all about preparing for the extreme. And unless you experienced an extreme event like Sandy in New York or Hurricane Ida, it can be pretty tough to explain what it brings. What is the disaster it can bring to a city like New York. And so I think growingly it is about preventing loss of life, maintaining communities, quality of life in neighborhoods. We cannot take that for granted anymore. So there's a tremendous need to step up and understand risk to much greater extremes. Stress tests, as we could also call it. Stress tests not just at the asset level, but at the regional scale, city scale, and even for the Netherlands or European countries, country scale. What does it bring downstream? So I think adaptation, resilience, those two words have gained much more meaning in recent years. And there's a strong overlay now with preparing for more extreme circumstances that we may not even comprehend at this stage.
For us, it's about keeping New Yorkers safe as the climate changes around us. Like New York City has already been reclassified as being in a humid subtropical environment. So that we really work across hazards, including all of the ones mentioned, big infrastructure projects like the coastal flood protections you're seeing on Lower Manhattan, as well as social resiliency. We actually have a program like that in New York called Be a Buddy, which is about calling your neighbors during heat events. Social resiliency is a really important piece of the puzzle. While we work across hazards, we know that heat and air quality are really the biggest environmental killers and the biggest threat to public health. Over 500 New Yorkers die every year from heat-related causes, and over 2,000 New Yorkers related to long-term exposure to PM 2.5. Just wanted to mention those hazards as well, because we've been talking a lot about water, but we really work across hazards and try to find co-benefit and multi-benefit solutions where possible.
Thank you very much for sharing. I hear like some overlaps and then the differences in different sectors too, but I also hear that urgency as well. I was just talking to Jennifer earlier during the break, but one thing I always think was it's urgent, but it is sometimes very difficult. Identifying risk and actually implementing the plan. So I wonder if you could share what would be the biggest barriers to translating climate assessments or identified risks or data into on-the-ground action. Maybe I will start with you, Edward.
I mean, adaptation is a verb, right? And resilience, becoming more resilient, means literally getting the shovel in the ground, being able to show actionable results. And just looking at Jamie's presentation with NTA, looking where NTA was standing before Sandy and where they're currently. Same with New York City, the big U. Same with how the city is handling stormwater. There's also like, it's a pre and there's an after. And it all comes down to getting work done to protect communities. And there are certain enablers to get there. And participatory planning, for example, is one of those enablers. So it's not a goal. Having fantastic collaboration with your community is of course something that you do want to celebrate at the end. But it's not the goal. The goal is to get the shovel in the ground and make people more resilient. And I think that's part of the shift that we are starting to see, that we are running out of time. And just to give you an example, a couple of years ago I was hosting the mayor of Rotterdam in New York, and he was wildly impressed by the scale of all the works that are happening. But also he was observing, you guys take a lot of time to talk. And do you have the luxury to do that going forward? Looking at certain climate scenarios, 2030 is around the corner. This very weekend there's a Keynote in Boston, so everyone is ready with their cameras to capture 2 feet of surge on top of a high tide. Water will be everywhere. So, the luxury of time and how you use time, how you design your processes around that, that was a big part of rebuild by design as well. Think about your process, don't take the process for granted. So governance is extremely important, and we are blessed with real good governance in New York. I can tell you guys, with the traffic in other cities where we don't have that in place. It's an enabler that we need, but at the end of the day, it's not the goal. The goal is to get the work done in order to protect communities, prevent loss.
Anybody interested in question, comment?
So I don't know if it's a barrier, but what comes to mind for me is missed opportunities. And what that means in practice is kind of also reflecting on what you heard from Jamie before. When a storm hits, even though you don't want to think of that as an opportunity, and for better or worse, that is when you need the plan in place to be able to get the funding, because there is inevitably political attention and typically funding available after an extreme event. So similar to MTA, DP had to do planning for extreme events when Sandy hit, and we were able to pick that up and apply for federal funding. Other barrier, like missed opportunity, is every time you do a significant repair project. Again, you heard that before from Jamie. When you do, for us, it's when we're complying with regulations like the Clean Water Act. That investment can double as also helping us to, well, either making an asset itself more resilient, or sizing it differently. For example, if it's a water control project, we can add added benefit for reducing flooding. And we invest a lot of money, and we have invested a lot of money in the past. Where if we were to do it today, we would probably do it a lot differently. Thanks to things like the climate resiliency design guidelines, which I'm sure Hildy you're about to talk about maybe sometime.
Sure. I mean, to pick that up, I guess thanks for the layup. The New York City is trying to find ways to bridge the scientific expertise that we have access through institutions like NYU and all of the regional universities that we work with our planning processes, and that's resulted in our climate resiliency design guidelines, currently in a mandated pilot phase, but to go live sometime next year. And when it goes live, it'll be the law of the land for all capital projects in New York City have to take into account future climate risk for the projected life of that asset. So that's across heat, stormwater flooding, and sea level rise. I just want to call out another big gap in reaching those ambitions is funding, and most specifically funding for heat. Sandy, that we talked about in earlier presentations, resulted in billions of dollars for the city. That was largely for coastal work to protect against a future coastal storm. There's co-benefits here and there, but heat events aren't named events, right? They're not something that we receive a lot of post funding for from the government, and it's something that is hugely important for the public health of New Yorkers going forward. So just to call that out.
Thank you. I mean, maybe 2 points. I think climate adaptation is inherently more complicated because we're talking about complicated systems that include different types of stakeholders. When you include different types of stakeholders with many different priorities and backgrounds, you spend time communicating or identifying how to communicate and translate those views across. And maybe anybody here has experience working in interdisciplinary fields knows how long it takes to understand the other field's language, right? So think about this when you're trying to do it with local communities, with transportation, water, policy. It's all different language. It takes time. It just fundamentally takes time to do all that work, especially if you want to be inclusive in that process, right? So if you want to go very quickly, someone's voice is not being heard. And at the same time as you're optimizing for adaptation, it's quite complicated to optimize for adaptation. When it comes to mitigation, we're talking about equivalent CO2 emissions. When we're talking about adaptation, we can talk about different metrics, whether it's downtime for power or delays for transportation, where all of those are very specific to the given system that we talk about. And as you optimize, again, it's a question of that give and take with the stakeholders. How do we reach that optimal agreement that everybody wants to agree with? And it just fundamentally takes time, both because it's a negotiation process, but also because it takes time to translate. And the second piece I just wanted to chime in on the financing side, there's been a lot of time about how do we finance adaptation. And I think a lot of the crux of it, to that point on how hard it is to finance some of the aspects is ultimately from the investing side, there's going to be the need for the cost-benefit analysis, and from the private capital, what is the return from that investment? And when we think about the different interventions that can be done for adaptation, the big question is, what is the value and who's capturing that value? So the value is very spread out, for example, it's a population that is benefiting. Then perhaps the financing mechanism is around things like municipal bonds, where it's the public sector that is issuing the bond, growing capital markets, But for example, it's not an intervention that can be invested directly by startup capital, or even necessarily by companies directly. Right? So depending on whether the value is distributed or concentrated, it also needs a different type of finance mechanism necessary.
Continue talking about that aspect of it as well. I think it's super tricky to figure out like how do you finance this stuff. There's a lot of thoughts that insurance companies should be able to look at things like charging you lower premiums, right? If you were putting adaptation in your home or your building, but that doesn't happen right now, and so it's a big problem. It's like having the reason to make it worthwhile to spend this money. There was actually though I feel like a big buzzy thing this week of cool catastrophe bond put out by an insurer of last resort in North Carolina recently, where it was a catastrophe bond is like you get paid out if the catastrophe exceeds a certain level of badness. That's the right word, right? It's like the winds in a certain area are so bad and you get a payout from it. But then they also have for years where the winds weren't that bad, they get a certain amount of money for roof adaptations in the community. So people are talking about that a lot. It's like maybe this is the first good example we see of how to do this. But I would also say, from my perspective, all of this becomes very hard from data as a data challenge, right? Because if you want to have a bond figure, you need to have a data back, right? You need things to track for this financing. The insurance company needs to know how much money are we saving on payouts so we can reduce rates. And from my future or from my past, I know that can be really hard even at the scale of New York City, right? But then when you're thinking in the world of finance, now you're thinking about the scale of the world, this data, it gets really hard. It gets really hard to tell you, how bad are heat waves going to be in New York City, but also in London, but also in Nairobi, right? It's just a difficult problem. I don't know that there's a short-term solution as we are limited by, downscaling climate models or whatever. But yeah, that's a huge challenge, and you have to be able to measure stuff to make it go fast.
Thank you. I love that this is a natural streamline from hearing to policy governance and then the pilots. So maybe I will continue the streamline starting from Haley asking a little bit more about safety as a whole perspective on how it's hard to coordinate this even city agencies and then trying to prevent all these working with other partners too. So if you can share a little bit of how you are coordinating with partners, agencies.
Yeah, I think NYC structures are a lot of our coordination around core sustainability and adaptation goals. And we meet very often. We have a group of folks across agencies working on climate, and we're in constant conversation. And part of my role is making sure across that group that folks are aware of the latest science that we're working on, the latest report findings, make sure we're always updating the local projections that we're using to plan. We also had a really exciting report come out this February called Securing a Resilient New York City, Funding and Financing Shoreline Protection. And it's, the city convened a working group to think about the most creative and impactful ways to actually pay for our coastal infrastructure, and they came up with some really creative and exciting options, including shoreline protection districts, so deciding who pays for this and how, creative communications and working with the insurance industry, of course, is a piece of that, as well as creating a resilience board. New York City's had a water board since the 80s that's helped us turn money that people pay for water into money that we use for stormwater projects. And so I'm excited to see that work take place, because I think it's really important, especially in this moment, to use all the tools at our disposal and work together across sectors.
Thank you very much for sharing. Since you mentioned water, so I'd like to go to Alan. So we get back into it a little bit more as if there's so much water. We said that, too much water is a problem, too less water is a problem. If you could share a little bit of your work and also Vicky's work around purge or water punishment, please.
Sure, yeah, and I just want to piggyback up some of the comments about, paying for it. We, in a lot of ways, know what to do, and there are technical and operational challenges, which I'll talk about in a second, but really focusing on too much water because, again, that is, I think, one of the biggest challenges we have right now. We can't forget about drought and be prepared for that. And there are multi-purpose solutions like water reuse that we have to consider, stormwater capture and reuse. That will, again, those are the more technical approaches. Paying for it is, right now financed by your water rate. So the amount of water that you use is determining how much money, basically not how much money you get paid, but how much money we invested back in our infrastructure and how it's made my salary as well. But we have to get more creative because we're trying to keep rates affordable for all New Yorkers. And so that means, the lowest income New Yorkers are really where we focus on keeping rates the most affordable. But I don't think that is going to be sustainable in the long run if we are going to invest at the pace we need to invest. So things like bonds, I think are going to become more and more serious considerations we can get pretty serious about innovative financing. Technically, though, there are constraints where we're going to put all this rainfall. We could build multi-billion-dollar tunnels. It is something that cities are doing. But again, you're back to how we're going to pay for it, who's going to pay for it. So it is part of the solution for sure. Putting solutions underground. We also are competing with subways and electrical conduits and all sorts of things. Bedrock. So it's not so hard, not so easy. So then we're looking above the surface to green infrastructure and absorbing water. And that is a solution we're also implementing. We need to do all of the above that has benefits for reducing urban heat islands and absorbing water before it gets into the sewer in the first place, which increases capacity. Last thing I'll say is, though, once you do that, you have to figure out who is maintaining it. We have thousands of rain gardens across the city now through our green infrastructure program, but not enough people to keep litter out of it on a daily basis. So we also need to innovate in terms of how we work with nonprofits, nonprofit partnerships. There's a workforce opportunity involved here. So I'll stop there. There's more, in all of this, I see opportunity. That's where
Great, thank you, Alan. Then let's shift to engineering and also projected delivery now. So Edgar, you work on adaptation, quite variety from coastal to other multi-hazards. So I was wondering if you could share what kind of engineering and also design approaches really helping cities adapt to more extreme events. And also if you can share what kind of funding or delivery models have helped more move those major adaptation projects forward.
Yeah, I mean, New York has come a long way in understanding also the business case behind adaptation. So adaptation done right is a tremendous opportunity. And we've touched on the business case a couple of times now. And I think oftentimes our horizon is not even big enough. Arcadis started working, for example, post-Katrina in New Orleans. Was it last year or earlier this year? We had Taylor Swift perform in New Orleans. We touched on the business case a couple of times now, and I think oftentimes our horizon is not even big enough. Arcadis started working, for example, post-Katrina in New Orleans. Was it last year or earlier this year? We had Taylor Swift perform in New Orleans. And we never thought that that would generate 250 million or 300 million in revenue over a weekend in New Orleans. And then we can ask ourselves, would that investment have come to the city if the city would not have been protected? So, I mean, defining a business case is a good result from investing in adaptation. And I think New York has come a long way, and part of that long way is designing infrastructure that can double as social infrastructure. We've heard that word a couple of times past few years, so it's not just the physical interventions, the walls, the gates, the pumps, the stuff that we engineers like to bring into our cities, but then how are you going to enjoy it? What is it going to look like? And maybe to ask you guys the question, who of you has seen the new East River Park? A couple of fingers. Many of you, very good. Not all of you. So I would very much welcome you all to visit that park. It has completely been redone. So try to read that landscape. What are you seeing? Same with East Side Coastal Resilience, just north of it. What does the flood protection plan actually look like? So multifunctionality is extremely important. How is that infrastructure going to behave and give value under normal circumstances? There's also an element, an engineering element that you don't see, and that's adaptive design. So we have an ability to upgrade the solution if need be. So if, say, circumstances change in the future and we foresee higher sea levels, we can upgrade the plan. The subsoil foundations, for example, the walls, allow for a 2 feet upgrade of the wall. So currently it protects for the 50-year sea level rise monitoring event. You can upgrade the alignment, like if need be. So adaptive design, multifunctionality also being part of that business case. Who do you invite to the table to have a conversation with when you design your plan? That is a path forward, because that's where the financial institutions could come in and help craft maybe what could become a resilience hub. Let's put the money on the table because we've defined a business case and an environment that can actually protect our communities. So that's where engineering, planning, investment can go hand in hand. And I think we are starting to see the pieces come together in New York. It's not quite yet, but it's coming. So fast forward 5 years from now, I think the city is in a great place.
That's so weird. That's great. I'm gonna ask one question. That makes me very happy. Great, thank you very much. So, as you mentioned, let's move into finance side. Maria, since you were an expert on data and also adaptation as well, so I wanted to hear your insights on types of data, climate, infrastructure, or anything use in general, or you think that are useful for assessing risks across multiple hazards, and also if you can share some insights on those data, like how they can support long-term resilience flooding.
Sure, yeah, I think this is something that is very tricky to do at any kind of scale, right? And so we see a lot of people coming to us telling us, what's my physical risk number? And that's just not a thing, right? It's a very complicated thing. You're looking at different hazards on different time scales. For example, wildfire, your risk is going to change year to year because if there was a fire last year, there's no fuel for a fire next year. Whereas hurricane risk isn't changing, it's changing for climate change, but a hurricane last year doesn't make it less likely to have a hurricane this year. And it gets really complicated, and you try to kind of put all of these into one number and answer how safe or how dangerous or how much should adaptation happen here. There are obviously industries that have done this for a long time, right? Like the insurance industry, catastrophe models, they need to have a good sense of your risk. A lot of those aren't considering climate change, though. On the other hand, you have climate models, which were developed not for this purpose at all and aren't really great for this purpose, where you're trying to take these incredibly large resolution models and then tell you, right here, what's your flood risk, right? And okay, so you're telling me the average annual temperature change in all of New York City, and now you're going to use that number to tell me my flood risk at 5 Metro Tech. I think that's the atmosphere. that's kind of crazy, right? And so there's this whole world that needs to kind of merge these approaches and figure out like how do you do that at any kind of scale. Now, if you're, you know, a certain, like if you're a city, especially a more well-resourced city, you can have panels of experts who can like, help you with these issues. But there are a lot of smaller towns that have no capacity to hire someone to help with this, right? And it's, you know, I think the problem going forward is probably for the US, it's a much bigger problem outside the US. We at least have some like the data resources for this kind of thing in the US. So yeah, I don't know, I feel like I'm always a naysayer whenever people ask me these questions. People are working on it, and the tricky thing is, on the other hand, this is like a moment where people want to invest in this. You have to give them an answer, right? And so the best we can do is try to give an answer, and then hopefully next year our answer's a little better, and then after that our answer's a little better. But I think there's a lot of work to be done on taking these, you know, scientific outputs and then making them actionable at a more local scale. That gap is being filled by, you know, for-profit data providers who may not be necessarily do the best job of it. And so I think it should be, you know, a government function, but that's a whole other conversation probably.
Thank you. It reminds me of a conversation with my prior life. But yeah, so Julio, if you could also share the perspective on finance and also the adaptation. I was wondering, like, your insights on advancement in climate modeling, climate projections, and there are more data sets, although it's very complex to choose, like Maria said, or to, you know, show you like certain numbers. But I wonder, like, what's your insights on those shaping adaptation planning and broader investment and also the infrastructure community?
There's a lot there. I'll start trying to answer. Feel free to dive in with more questions. I think it's important to maybe think about how we got here as well. I mean, as Brian said, like, a lot of the focus here has been on climate modeling. You know, a lot of these models, whether it's physical climate models like what we see in the IPCC and CH6, or integrated assessment models more on the economic side and technology side. Those were models designed for academic research and policy implications, less so for business use cases and financial decision making. Having said that, they can still provide some value for that. And so, you know, in absence of anything else, when we started, you know, generally the sector started looking at this 10 years ago, 5 years ago, that's what was available, and that's what, you know, version 1 of climate analytics started looking at. You know, how can we take CWIP5 and downscale it, now CWIP6 and downscale it, build hazard models on top of it. A lot of this ended up being done in the startup world, the private sector world. There's an idea a lot of the times, you know, faculty, for example, focus on specific hazards. So that there's the expert in flooding, the expert in tropical cyclone, the expert in drought. But as Brian was saying, you know, an investor is not just looking for the flooding result. They want to know, like, what is going to be beneficial to flood, to fire, to tropical cyclone, to drought, to heat wave. And like basically, the companies that started working on this, they started putting together all of these hazards, a bit of a hodgepodge, putting it together into a single, not necessarily a single number, but at least a consistent set of numbers that could somewhat be interpreted together. I would say that the version 2 of applied analytics where we are now is a bit more nuanced, where we're thinking more about a specific asset, a specific decision making. We're trying to do a lot of the initial startups in the space. We're very general, basically anybody who wanted, here's some climate analytics. Now there's a lot more focus on, are you a real estate investor? Here's climate analytics for real estate. Are you a utilities investor? Here's a look at climate analytics for utility. And that provides a little bit more nuance in terms of like the variables, the mounting that's required for a specific asset. I think one really exciting development that's happening right now is with to jump into the buzzword train, the AI, climate, and weather modeling. I mean, you might see more on the AI weather modeling. There's like really interesting advances over the last couple of years of models that are trained on numerical weather predictions, now being able to replicate that type of weather forecast in fraction of the time and fraction of the computing power. That is being now extended to climate modeling as well. We start including not just the atmosphere, but also the ocean and the land component. And that is very powerful because it's also hopefully unlocking our ability to predict some of these hazards or at least the increasing or decreasing risk of some of these hazards at time horizons beyond the 2 weeks, which is what it is, but shorter horizons than decades, which is kind of what climate models are focusing on. So we start to think about the next generation of climate analytics that are purpose built for decision making in the private sector, where you just don't want to rely on the next, the last set of results that are not going to update for another 5 years. We want to get an update, for example, okay, given El Nino, La Nina today, what is my risk of the next year? We also initialize that kind of condition. That's where the AI cloud models are going to be playing a really interesting role in the future. Obviously, it's still very much in research and development, but I think it's really exciting.
Thank you very much. So I know it's Friday and it's getting late, and also I asked already a lot of questions. So I'd like to open to the floor for maybe a couple questions.
You mentioned water mitigation is a really great opportunity. I was wondering if you could speak on some of the opportunities that you can use water mitigation to also enhance water quality. I heard about the Building Oyster project recently and also the wedge design guidelines. So wondering if you could speak on that. Thank you.
Sure. Yeah. I mean, this is where nature-based solutions, for example, come in. Marshlands restoration, and also translating that question to a place like New York. We know we're 520 miles of coastline, so pairing water quality with water resilience, waterfront resilience, we'll see a lot more in that space. Nature-based right now is still working with nature eco-engineering and those practices, solutions that we are starting to see, still at a humble scale, I would say. We will see that scaled up. It's happening in Louisiana, it's happening in the Bay Area, San Francisco, and we'll see it also much more in New York City area. But this is definitely a space where water quality and water resilience will go hand in hand.
Thank you. Other questions?
Thank you. So you discussed a lot how current climate models and current more specific insurance company models don't take into account climate change, and current climate models aren't really usable for specific insurance evaluations. What does the process of fixing that look like? You went into it a little bit with we're starting to design more specific models, more industry specific models. But is there a feasible way to integrate climate change modeling into insurance company modeling, or are we just kind of sitting in a blind zone in regards to getting modeling that specific?
Let's speak to that a little. I'd say, first of all, a lot of the catastrophe modeling companies are starting to do this, right? And it's generally just something that, starting with something pretty simplistic, which is we take the histogram of what our model outputs would be, and now we know that the climate models tell us the rainfall is going to be 10% worse, so we shifted 10% to the right or whatever it is. So people are starting to do it. I think this is almost certainly another thing you see is for AI and AI downscaling. Things that are using less compute power but more sophisticated than some of the super simple statistical models. There are some cool startup-y, forward cap models that are starting their own companies to try to solve these issues. So I think there's going to be progress. The results of that progress are going to be really expensive if you want to see that, unfortunately. But there's certainly people thinking about this and doing really interesting work.
If you don't mind, I'll take the last question. So we're in a school of engineers. We have a bunch of dedicated students that have to stay here until 6 p.m. on Friday. I think many of you have professional careers that are not that common for engineers. What are opportunities for engineers, regardless of the field that they take in finance, public government, any engineering, adaptation, big projects that we see coming?
Very valid points.
I would say, I mean, one of the exciting things in a way, I mean, obviously it's a very stressful situation where we have to choose, but one of from a career perspective, there's basically we need to mitigate across sectors, and those need to adapt, across geographies. So regardless of what is your interest, whether it's in medical engineering, whether your interest is in energy or fashion, there is opportunity across. It's kind of like thinking about what you feel passionate about in terms of the sector, what sector you really like learning more about, and what are the needs of that sector, whether it's about mitigation or adaptation. But I mean, one thing that I've been learning, I also came to finance like 4.5 years ago, and I never thought I would end up here. But as we've discussed, to kind of the question of like, who's a grade is a huge one. So having an angle to that, even if you're not in the industry, so like keeping an eye on like how things are a very important question.
I think to build, I mean, we've seen and heard a lot about investment, right? We all want to make our worlds better. I think the NTA presentation gave was also a good example. It's about safeguarding, protecting. I think the engineering industry, you guys will also become familiar with an environment where decommissioning, de-investment is going to be a prime topic. Because we simply cannot engineer our way out of the troubles ahead of us. This was actually a question I wanted to ask you. Like, is this even part of your, say, 2070 data scenario where we treat decommissioning, de-investment, whatever word you want to use for that, is that even part of your strategy at this point, or would you foresee it to be part of your strategy? Because it brings a whole new discipline to our engineering practice that we currently are not really familiar with, even the questions that relate to it. We are starting to explore it. In Colombia 2 years ago, had a conference that one point managed retreat. I think I replanted the conference a year later because it was a little too much. But this is exactly what is ahead of us, and we are not talking enough about it. But organizations like the American Society of Civil Engineers, ASCE, are currently going through the revision of the sustainability standard. I'm on the committee on the board of them. This is what we are talking about when we define and discuss the definition of resilience. This is it. It's not just maintaining, safeguarding, good housekeeping, all the things from the past. No, it's about a future that is uncertain and that requires different thinking, different disciplines. And yes, we have the blessing of AI and data and the way we explain our business case. But it will change the industry for sure. And I think that's a tremendous opportunity for you guys.
How's that? So I've worked in the city with, I think, 5,000 people and a large quantity of engineers. And so we need engineers. We're always saying we need engineers. I think the key kind of building of what Edgar is thinking about some of the solutions. There's some really grand visions out there. When after Sandy, the artist rendering sort of of the big U seemed pretty out there, but now there's the cycles for resiliency. So I think it's up to the engineers to keep an open mind, but also for people help thread like what's the reality, feasibility, costs. Are things that I've heard quite a bit. But having a conversation, engaging in the conversation, I will say like there is, a bit, there are people that will laugh you out of the room, but we have to come together. We need some silly ideas in the mix, and maybe we need to find a middle ground, in this to actually come up with a solution.
I can see more personal information possibly, but I was thinking it's funny. So I had a degree in biological and environmental engineering, and then I worked at Malcolm Fermi, which was an engineering discipline that got thought by Arcadis for a few years. Then I went to grad school with Julio and got my PhD in hydrology. And I was a professor at Brooklyn College. I actually worked with Alan a bit on New York City flooding. Then I was a data scientist for a few years in tech, nothing to do with the environment at all. And now I work in climate and physical risk data at a bank. So,
happy to take you back.
who knows what the point is going to be? Like, to be flexible, right? The world is changing so much, especially when it comes to these things. You know, when I finished undergrad, like, or even grad school, probably was like data science wasn't a career, right? And then I found myself as a data scientist. And then certainly when I finished grad school, even kind of like climate in finance was not prepared. But now I'm here. So like, who knows where I'll be in 5 years? I mean, don't tell, you know, my ideas with that. But I think it's important to just stay flexible, stay open. It's kind of fun, I think, to work at the intersection of like weird groups coming together that you don't necessarily see coming together, and the key to that is flexibility and communication. Develop people. I think you should celebrate is very important. But yeah, I mean, you know, you'll find a winding path at some point and stay open. Yeah.
Right. I think it's 6 o'clock. I think we have had wonderful talks and wonderful discussions. Thank you so much. Let's thank your Thanks to all of you for coming. Especially thank you to George Gonzalez. I'm not George in the room. So George was behind putting all this together, probably outside, getting everything ready for our reception. So again, thank you for coming. Stay engaged. There's a lot of opportunities here in school to get engaged with sustainability work, research, translation, and more broadly across the city. So thank you for coming, and please go enjoy for the reception and do the samples.